mentioned the startup of PayPal, which is a great innovation that happened in sort of how we pay for things. That seems to me an area in which there hasn't been as much subsequent innovation other than Bitcoin as there should be. In other words, quickly transferring money, especially to people you don't know or whatever, is, to me, maybe I'm wrong, far more difficult than it seems like it should be. Are you somewhat disappointed with the way PayPal then proceeded, or are you disappointed with the lack of innovation in the digital currency environment?
Yeah, PayPal has definitely, I mean, it hasn't moved much since from when it was sort of bought by eBay. The long-term vision that I had for PayPal, or sort of in sort of finance, was to well, it sounds a bit strange, like to convert the financial system from a series of heterogeneous, insecure databases to one database. Mm-hmm. Or, well, not one database, but maybe there'd be like a few more. The money is just a number in a database. That's what it is. And it's primarily an information mechanism for labor allocation. And the current databases are not very efficient. Like there are these old legacy mainframes that don't talk to each other very well, have poor security, and only do batch processing once a day.
Are you glad PayPal is being spun off?
It's probably the right move.
And what would you do with it?
Well, I think I converted it into more of a full-service financial institution. So you want to do all the things that a consumer. You want to have like all the financial services that somebody needs in one place, seamlessly integrated together and easy to use. And I think really care about the consumer. I think a lot of banks don't seem to care that much about the customer. So I think there's an opportunity to be like a really good bank, effectively, but much more than what people think of as.
Do you think Bitcoin will be disruptive in that way? I mean, now it's a speculative currency. Will it be something that will be what normal consumers will use and will disrupt the banking industry?
My opinion of Bitcoin is that, I think Bitcoin is probably a good thing, but it's essentially, its main thing will be, I mean, this will probably get quoted here and there, but I think it's primarily going to be a means of doing illegal transactions. But that's not necessarily entirely bad, because some things shouldn't be illegal. But
the combination of Silk Road and Bitcoin will save us?
Well, it will be useful for legal and illegal transactions. Otherwise, it would have no value as a use for a legal transaction, because you have to have a legal to illegal bridge.
Yeah.
So let me be the guy. You posted a meme on Twitter recently where there's like a row of urinals. A guy just walks all the way across.
Oh, sure, yeah.
And he tells you about crypto.
Listen, I mean, that's happened to me so many times. I think maybe even literally.
Yeah. Do you think, technologically speaking, there's any room for ideas of smart contracts or so on? Because you mentioned laws. That's an interesting use of things like smart contracts to implement the laws by which governments function. Like something built on Ethereum, or maybe a dog coin that enables smart contracts somehow.
I don't quite understand this whole smart contract thing. I mean,
so
I'm too dumb to understand smart contracts.
That's a good line.
I mean, my general approach to any kind of like deal or whatever is just make sure there's clarity of understanding. That's the most important thing.
Right.
And just keep any kind of deal very, very short and simple, plain language, and just make sure everyone understands this is the deal. Is it clear? And what are the consequences if various things don't happen? But usually deals are, business deals or whatever are way too long and complex and overly lawyered and pointlessly.
You mentioned that Doge is the people's coin.
Yeah.
And you said that you were literally SpaceX may consider literally putting a Doge coin on the moon. Is this something you're still considering? Mars, perhaps? Do you think there's some chance, we've talked about political systems on Mars, that Dogecoin is the official currency of Mars at some point in the future?
Well, I think Mars itself will need to have a different currency because you can't synchronize due to speed of light. Or not easily.
So it must be completely standalone from Earth.
Well, yeah, because the Mars is at closest approach, it's 4 light minutes away roughly, and then at furthest approach, it's roughly 20 light minutes away, maybe a little more. So you can't really have something synchronizing. If you've got a 20-minute speed of light issue, if it's got a 1-minute blockchain, it's not going to synchronize properly. So Mars would. I don't know if Mars would have a cryptocurrency as a thing, but probably seems likely. But it would be some kind of localized thing on Mars.
And you let the people decide.
Yeah, absolutely. The future of Mars should be up to the Martians. So I mean, I think the cryptocurrency thing is an interesting approach to reducing the error in the database that is called money. I think I have a pretty deep understanding of what money actually is on a practical day-to-day basis because of PayPal. We really got in deep there. And right now, the money system, actually, for practical purposes, is really a bunch of heterogeneous mainframes running old COBOL.
Okay, you mean literally? That's
literally
that is literally what's happening
in batch mode. Okay,
in batch mode.
Yeah, I pity the poor bastards who have to maintain that code. Okay, that's a pain. That's pain.
Not even Fortran. It's COBOL. Yep,
it's COBOL. And the banks are still buying mainframes in 2021 and running ancient COBOL code. The Federal Reserve is like probably even older than what the banks have, and they have an old COBOL mainframe. And so now, so the government effectively has editing privileges on the money database, and they use those editing privileges to make more money whenever they want, and this increases the error in the database that is money. So I think money should really be viewed through the lens of information theory, and so it's kind of like an internet connection. Like, what's the bandwidth? Total bit rate. What is the latency, jitter, packet drop? Errors in the network communication. Just think of money like that, basically. I think that's probably the right way to think of it. And then say what system, from an information theory standpoint, allows an economy to function the best, and crypto is an attempt to reduce the error in money that is contributed by governments diluting the money supply as basically a pernicious form of taxation.
So both policy in terms of with inflation and actual like technological cobalt, like cryptocurrency takes us into the 21st century in terms of the actual systems that allow you to do the transaction, to store wealth, all those kinds of things.
Like I said, just think of money as information. People often will think of money as having power in and of itself. It does not. Money is information, and it does not have power in and of itself. Again, applying the physics tools of thinking about things in the limit is helpful. If you are stranded on a tropical island, and you have $1 trillion, it's useless because there's no resource allocation. Money is a database for resource allocation, but there's no resources to allocate except yourself. So money is useless. If you're stranded on a desert island with no food, all the Bitcoin in the world will not stop you from starving.
Yeah.
So, like just think of money as a database for resource allocation across time and space, and then what system it is, in what form should that database or data system, what would be most effective? Now, there is a fundamental issue with say Bitcoin in its current form, in that the transaction volume is very limited, and the latency the latency for a properly confirmed transaction is too long, much longer than you'd like. So it's actually not great from a transaction volume standpoint or a latency standpoint. So it is perhaps useful as to solve an aspect of the money database problem, which is this sort of store of wealth or an accounting of relative obligations, I suppose. But it is not useful as a currency, as a day-to-day currency.
But people have proposed different technological solutions,
like Lightning.
Lightning Network and the layer 2 technologies on top of that. I mean, it seems to be all kind of a trade-off, but the point is, it's kind of brilliant to say that just think about information, think about what kind of database, what kind of infrastructure enables that exchange of
like
information.
You're operating an economy, and you need to have something that allows for the to have efficient value ratios between products and services. So you've got this massive number of products and services, and you need to, you can't just barter. It's like, that would be extremely unwieldy. So you need something that gives you a ratio of exchange between goods and services, and then something that allows you to shift obligations across time, like debt and equity, shift obligations across time. Then what does the best job of that? Part of the reason why I think there's some merit to Dogecoin, even though it was obviously created as a joke, is that it actually does have a much higher transaction volume capability than Bitcoin, and the cost of doing a transaction, the Dogecoin fee is very low. Like right now, if you want to do a Bitcoin transaction, the price of doing that transaction is very high, so you could not use it effectively for most things, and nor could it even scale to a high volume. And when Bitcoin was started, I guess around 2008 or something like that, the internet connections were much worse than they are today, like order of magnitude there's the way worse, in 2008. So like having a small block size or whatever is, and a long synchronization time made sense in 2008. But to 2021 or fast forward 10 years, it's like comically low. It's and I think there's some value to having a linear increase in the amount of currency that is generated. So because some amount of the currency, if a currency is too deflationary, or should say if a currency is expected to increase in value over time, there's reluctance to spend it. Because you're like, I'll just hold it and not spend it because its scarcity is increasing with time. So if I spend it now, then I will regret spending it. So I will just, hodl it. Mm-hmm. But if there's some dilution of the currency occurring over time, that's more of an incentive to use it as a currency. So Dogecoin, somewhat randomly, has just a fixed number of sort of coins or hash strings that are generated every year. So there's some inflation, but it's not a percentage base. It's a fixed number. So the percentage of inflation will necessarily decline over time. So I'm not saying that it's like the ideal system for a currency, but I think it actually is just fundamentally better than anything else I've seen, just by accident.
I like how you said around 2008. So you're not, some people suggested you might be Satoshi Nakamoto. You previously said you're not. Let me ask. Not. You're not, for sure. Would you tell us if you were?
Yes.
Okay. Do you think it's a feature or bug that he's anonymous, or she, or they? It's an interesting kind of quirk of human history that there is a particular technology that is a completely anonymous inventor or creator.
Well, I mean, you can look at the evolution of ideas before the launch of Bitcoin and see who wrote, about those ideas, and then I don't know exactly. Obviously, I don't know who created Bitcoin for practical purposes, but the evolution of ideas is pretty clear before that, and it seems as though Nick Szabo is probably more than anyone else responsible for the evolution of those ideas. So, he claims not to be Nakamoto, but I'm not sure that's neither here nor there. But he seems to be the one more responsible for the ideas behind Bitcoin than anyone else.
So it's not perhaps singular figures aren't even as important as the figures involved in the evolution of ideas that led to a thing. So
yeah,
it's perhaps it's sad to think about history, but maybe most names will be forgotten anyway.
What is a name anyway? It's a name attached to an idea. What does it even mean, really? So what advice do I have for college graduates interested in getting involved in the spheres you've tapped into? Certainly I'd invite you to apply for a job at Solar City or Tesla or SpaceX. If not, then if that doesn't work for whatever reason, then I guess apply to jobs at other companies in that arena, or try starting a company. When my brother and I were starting our first company, instead of getting an apartment, we just rented a small office and we slept on the couch. And we showered at the YMCA, and we're so hot up we had just one computer, so the The website was up during the day, and I was coding at night. 7 days a week, all the time. Work hard, like, every waking hour. That's the thing I would say, particularly if you're starting a company. And if you do simple math, you say like, okay, if somebody else is working 50 hours and you're working 100, you'll get twice as much done in the course of a year as the other company.
What is the one thing that has surprised you about your life?
I'm surprised by the whole thing, honestly. I just knew I wanted to be involved in technology, and in fact, the only reason I started a company back in '95, an internet company, was because I couldn't get it. There were only a few internet companies, and I couldn't get a job at any of them. So I tried to get a job at Netscape, and sent my resume in and tried hanging out in the lobby, but I was too shy to talk to anyone. And then I was like, okay, well, I guess I'll have to start a company because I can't get a job anywhere. If you want to do something really innovative, you have to apply a sort of first principles analysis, and don't reason by analogy. Analogies are referencing the past. First principles means you look at the most fundamental truths in a particular arena, and the things that really are almost indisputably correct, and you reason up from there to a conclusion. And if you see that conclusion is at odds with what people generally believe, then you have an opportunity. The other thing I'd say is that if you're creating a company or if you're joining a company, the most important thing is to attract great people. So either join a group that's amazing, that you really respect, or if you're building a company, you've got to gather great people. All a company is a group of people that have gathered together to create a product or service. And so depending upon how talented and hardworking that group is, and the degree to which they are focused cohesively in a good direction, that will determine the success of the company. So do everything you can to gather great people if you're creating a company.
One thing I really like about you is you are unusually fearless and willing to go in the face of other people telling you something is crazy. And I know a lot of pretty crazy people, you still stand out. Where does that come from, or how do you think about making a decision when everyone tells you this is a crazy idea? Or where do you get the internal strength to do that?
Well, first of all, I'd say I actually think I feel fear quite strongly. So it's not as though I just have the absence of fear. I feel it quite strongly. But there are just times when something is important enough, you believe in it enough, that you do it in spite of the fear. When starting SpaceX, I thought the odds of success were less than 10%. And I just accepted that actually probably I would just lose everything. But that maybe would make some progress. If we could just move the ball forward, even if we died, maybe some other company could pick up the baton and keep moving it forward, so that would still do some good. Yeah, same with Tesla. I thought the odds of a car company succeeding were extremely low. I was at sort of a slight existential crisis because I was trying to figure out what does it all mean? Like, what's the purpose of things? And I came to the conclusion that if we can advance the knowledge of the world, if we can do things that expand the scope and scale of consciousness, then we're better able to ask the right questions and become more enlightened, and that's really the only way forward. So I studied physics and business because I figured in order to do a lot of these things, you need to know how the universe works, and you need to know how the economy works. And you also need to be able to bring a lot of people together to work with you to create something, because it's very difficult to do something as an individual if it's a significant technology.
What drives you? What is it that when you wake up in the morning, do you see a problem and you want to solve it?
I think the thing that drives me is that I want to be able to think about the future and feel good about that. That we're doing what we can to have the future be be as good as possible, to be inspired by what is likely to happen, and to look forward to the next day. So that's what really drives me is trying to figure out how to make sure that things are great and going to be so, and that's the underlying principle behind Tesla and SpaceX. Is that I think it's pretty important that we accelerate the transition to sustainable generation and consumption of energy. It's inevitable, but it matters if it happens sooner or later. And then SpaceX is about helping make life multiplanetary, and doing what we can to continue the dream of Apollo, and ultimately make contribution to life becoming multiplanetary. And then I think the final thing I would encourage you to do is, now is the time to take risk. As you get older, your obligations increase. So and once you have a family, you start taking risk not just for yourself, but for your family as well. It gets much harder to do things that might not work out. So now is the time to do that. Before you have those obligations. So I would encourage you to take risks now, do something bold. You won't regret it. Thank you.
The following is a conversation with Elon Musk, his third time on this, the Lex Friedman podcast. Yeah, make yourself comfortable.
Boo.
No, wow, okay.
No. You don't do the headphones thing?
No.
Okay.
Right.
I mean, how close do I need to get this thing?
The closer you are, the sexier you sound.
Hey, babe. What's
Yep.
up? Can't get enough of your love, baby.
I'm going to clip that out anytime somebody messages me about
If you want my body and you think I'm sexy, come right out and tell me so. do.
So good. Okay, serious mode activate. All right.
Serious mode. Come on, you're Russian. You can be serious.
Yeah, I know.
Everyone's serious all the time in Russia.
Yeah. Yeah. But we'll get there. We'll get there.
Yeah.
It's gotten soft. Allow me to say that the SpaceX launch of human beings to orbit on May 30th, 2020 was seen by many as the first step in a new era of human space exploration. These human spaceflight missions were a beacon of hope to me and to millions over the past 2 years as our world has been going through one of the most difficult periods in recent human history. We see the rise of division, fear, cynicism, and the loss of common humanity right when it is needed most. So first, Elon, let me say thank you for giving the world hope and reason to be excited about the future.
Oh, it's kind of you to say. I do want to do that. Humanity has obviously a lot of issues, and you know, people at times do bad things, but you know, despite all that, you know, I love humanity, and I think we should make sure we do everything we can to have a good future and an exciting future, and one where that maximizes the happiness of the people.
Let me ask about Crew Dragon Demo 2. So that first flight with humans on board, how did you feel leading up to that launch? Were you scared? Were you excited? What was going through your mind? So much was at stake.
Yeah, no, that was extremely stressful, no question. We obviously could not let them down in any way. So extremely stressful, I'd say, to say the least. But I was confident that at the time that we launched, that no one could think of anything at all to do that would improve the probability of success. And we racked our brains to think of any possible way to improve the probability of success. We could not think of anything more, and nor could NASA. And so then that's just the best that we could do. So then we went ahead and launched. Now, I'm not a religious person, but I nonetheless got on my knees and prayed for that mission.
Were you able to sleep?
No.
How did it feel when it was a success? First, when the launch was a success, and when they returned back home or back to Earth?
It was a great relief. Yeah. It's for high stress situations, I find it's not so much elation as relief. You know, I think once as we got more comfortable and proved out the systems, because you know we really you know, you got to make sure everything works. It was definitely a lot more enjoyable with the subsequent astronaut missions, and I thought the Inspiration mission was actually very inspiring. The Inspiration 4 mission. I'd encourage people to watch the Inspiration documentary on Netflix. It's actually really good, and it really is inspired. I was actually inspired by that, and I so that one I felt I was kind of able to enjoy the actual mission and not just be super stressed all the time.
So for people that somehow don't know, it's the all-civilian, first time all-civilian out to space, out to orbit.
Yeah, and it was I think the highest orbit that in like, I don't know, 30 or 40 years or something. The only one that was higher was the one shuttle, a Hubble servicing mission. And then before that, it would have been Apollo in 72. It's pretty wild. So it's cool. It's good. You know, I think as you know, as a species, like we want to be, you know, continuing to do better and reach higher ground, and like I think it would be tragic, extremely tragic, if Apollo was the high watermark for humanity, you know, and that's as far as we ever got. And it's concerning that here we are, 49 years after the last mission to the moon, and so almost half a century, and we've not been back. And that's worrying. It's like, does that mean we've peaked as a civilization or what? So like, I think we got to get back to the moon and build a base there, you know, a science base. I think we could learn a lot about the nature of the universe if we have a proper science base on the moon. You know, like we have a science base in Antarctica and, you know, many other parts of the world. And so that's I think the next big thing. We've got to have like a serious like moon base, and then get people to Mars and, you know, get out there and be a spacefaring civilization.
I'll ask you about some of those details, but since you're so busy with the hard engineering challenges of everything that's involved, are you still able to marvel at the magic of it all, of space travel, of every time the rocket goes up, especially when it's a crewed mission? Or are you just so overwhelmed with all the challenges that you have to solve? And actually, sort of to add to that, the reason I wanted to ask this question of May 30th, it's been some time, so you can look back and think about the impact already. It's already, at the time, it was an engineering problem, maybe. Now it's becoming a historic moment. Like, it's a moment that, how many moments will be remembered about the 21st century? To me, that or something like that, maybe Inspiration 4, or one of those would be remembered as the early steps of a new age of space exploration.
Yeah, I mean, during the launches itself. So I mean, I think maybe some people know, but a lot of people don't know. Is like I'm actually the chief engineer of SpaceX. So, I've signed off on pretty much all the design decisions, and so if there's something that goes wrong with that vehicle, it's fundamentally my fault. So I'm really just thinking about all the things that, like, so when I see the rocket, I see all the things that could go wrong and the things that could be better. And the same with the Dragon spacecraft. It's like other people say, oh, this is a spacecraft or a rocket, and this looks really cool. I'm like, I've like a readout of like, these are the risks, these are the problems. That's what I see. Like, so it's not what other people see when they see the product, So
let me ask you then to analyze Starship in that same way. I know you'll talk about in more detail about Starship in the near future, perhaps.
We can talk about it now if you want.
But just in that same way, like you said, when you see a rocket, you see a sort of a list of risks. In that same way, you said that Starship is a really hard problem. So there's many ways I can ask this, but if you magically could solve one problem perfectly, one engineering problem perfectly, which one would it be?
On Starship?
On Starship. So is it maybe related to the efficiency, the engine, the weight of the different components, the complexity of various things, maybe the controls of the crazy thing it has to do to land?
No, it's actually by far the biggest thing absorbing my time is engine production. Not the design of the engine. I've often said prototypes are easy, production is hard. So we have the most advanced rocket engine that's ever been designed. Because I say currently the best rocket engine ever is probably the RD-180 or RD-170. That's the Russian engine basically. And still, I think an engine should only count if it's gotten something to orbit. So our engine has not gotten anything to orbit yet, but it's the first engine that's actually better than the Russian RD engines, which were amazing design.
So you're talking about Raptor engine. What makes it amazing? What are the different aspects of it that make it, like, what are you the most excited about if the whole thing works? In terms of efficiency, all those kinds of things.
Well, Raptor is a full flow staged combustion engine, and it's operating at a very high chamber pressure. So one of the key figures of merit, or perhaps the key figure of merit, is what is the chamber pressure at which the rocket engine can operate? That's the combustion chamber pressure. So Raptor is designed to operate at 300 bar, possibly maybe higher. That's 300 atmospheres. So the record right now for operational engine is the RD engine that I mentioned, the Russian RD, which is, I believe, around 267 bar. And the difficulty of the chamber pressure increases on a nonlinear basis. So 10% more chamber pressure is more like 50% more difficult. But that chamber pressure is that is what allows you to get a very high power density for the engine. Enabling a very high thrust to weight ratio and a very high specific impulse. So specific impulse is like a measure of the efficiency of a rocket engine. Or it's really the effective exhaust velocity of the gas coming out of the engine. With a very high chamber pressure, you can have a compact engine that nonetheless has a high expansion ratio, which is the ratio between the exit nozzle and the throat. So engines got, like, you see a rocket engine's got like sort of like a hourglass shape. It's like a chamber, and then it necks down, and then there's a nozzle, and the ratio of the exit diameter to the throat is expansion ratio.
So why is it such a hard engine to manufacture at scale?
It's very complex.
So a lot of what does complexity mean here? There's a lot of components involved.
There's a lot of components and a lot of unique materials that so we had to invent several alloys that don't exist in order to make this engine work.
So it's a materials problem too.
It's a materials problem, and in a staged combustion, a full flow staged combustion, there are many feedback loops in the system. So basically you've got propellant and hot gas flowing simultaneously to so many different places on the engine, and they all have a recursive effect on each other. So you change one thing here, it has a recursive effect here. It changes something over there, and it's quite hard to control. There's a reason no one's made this before. But and the reason we're doing a staged combustion full flow is because it has the highest theoretical possible efficiency. So in order to make a fully reusable rocket, which that's really the holy grail of orbital rocketry, you have to have everything's got to be the best. It's got to be the best engine, the best airframe, the best heat shield, extremely light avionics, very clever control mechanisms. You've got to shed mass in any possible way that you can. For example, instead of putting landing legs on the booster and ship, we are going to catch them with a tower to save the weight of the landing legs. So that's like, we're talking about catching the largest flying object ever made on a giant tower with chopstick arms. It's like Karate Kid with the fly, but much bigger.
Pulling something
this
like
probably
that
won't work the first time. Anyway, so this is bananas. This is banana stuff.
So you mentioned that you doubt. Well, not you doubt, but there's days or moments when you doubt that this is even possible. It's so difficult.
The possible part is, well, at this point, I think we'll get Starship to work. There's a question of timing. How long will it take us to do this? How long will it take us to actually achieve full and rapid reusability? Because it will take probably many launches before we're able to have full and rapid reusability. But I can say that the physics pencils out. We're not at this point. I'd say we're confident that let's say I'm very confident success is in the set of all possible outcomes.
Right. It's not an all set.
For a while there, I was not convinced that success was in the set of possible outcomes, which is very important, actually. But so we were.
So you're saying there's a chance.
I'm saying there's a chance, exactly.
Right, cool.
Just not sure how long it will take. But we have a very, very talented team. They're working night and day to make it happen. And like I said, the critical thing to achieve for the revolution in spaceflight and for humanity to be a spacefaring civilization is to have a fully and rapidly reusable orbital rocket. There's not even been any orbital rocket that's been fully reusable ever, and this has always been the holy grail of rocketry. Many smart people, very smart people, have tried to do this before and have not succeeded. So, because it's such a hard problem.
What's your source of belief in situations like this? When the engineering problem is so difficult, there's a lot of experts, many of whom you admire, who have failed in the past.
Yes.
And a lot of people, you know, a lot of experts, maybe journalists, all the kind of, you know, the public in general have a lot of doubt about whether it's possible. And you yourself know that even if it's a non-null set, non-empty set of success, it's still unlikely or very difficult. Like, where do you go to, both personally, intellectually, as an engineer, as a team, like for source of strength needed to sort of persevere through this and to keep going with the project, take it to completion?
A source of strength. I that's really not how I think about things. I mean, for me, it's simply this is something that is important to get done, and we should just keep doing it, or die trying. And I don't need a source of strength.
So quitting is not even like
it's not in my nature.
Okay.
And I don't care about optimism or pessimism. Fuck that. We're gonna get it done.
Gonna get it done. Can you then zoom back in to specific problems with Starship or any engineering problems you work on? Can you try to introspect your particular biological neural network, your thinking process, and describe how you think through problems, through different engineering and design problems? Is there like a systematic process? You've spoken about first principles thinking, but is there a kind of process to it?
Well, yeah, I like saying like physics is a law and everything else is a recommendation. Like I've met a lot of people who can break the law, but I haven't met anyone who could break physics. So the first, for any kind of technology problem, you have to sort of just make sure you're not violating physics. And first principles analysis, I think, is something that can be applied to really any walk of life, anything really. It's really just saying, let's boil something down to the most fundamental principles, the things that we are most confident are true at a foundational level, and that sets your axiomatic base, and then you reason up from there, and then you cross-check your conclusion against the axiomatic truths. Some basics in physics would be like, are you violating conservation of energy or momentum or something like that? Then it's not going to work. That's so that's just to establish is it possible? And then another good physics tool is thinking about things in the limit. If you take a particular thing and you scale it to a very large number or to a very small number, how do things change?
Both like like in number of things you manufacture or something like that, and then in time.
Yeah, like let's say take an example of like manufacturing, which I think is just a very underrated problem. And like I said, it's much harder to take an advanced technology product and bring it into volume manufacturing than it is to design it in the first place, by orders of magnitude. So let's say you're trying to figure out is why is this part or product expensive? Is it because of something fundamentally foolish that we're doing, or is it because our volume is too low? And so then you say, okay, well, what if our volume was 1 million units a year? Is it still expensive? That's what I mean by thinking about things in the limit. If it's still expensive at 1 million units a year, then volume is not the reason why your thing is expensive. There's something fundamental about the design.
And then you then can focus on the reducing the complexity or something like that in the design.
You got to change the design to change the part to be something that is not fundamentally expensive. But like that's a common thing in rocketry because the unit volume is relatively low, and so a common excuse would be, well, it's expensive because our unit volume is low. And if we were in like automotive or something like that, or consumer electronics, then our costs would be lower. I'm like, okay, so let's say now you're making 1 million units a year. Is it still expensive? If the answer is yes, then economies of scale are not the issue.
Do you throw into manufacturing? Do you throw like supply chain? You talked about resources and materials and stuff like that. Do you throw that into the calculation of trying to reason from first principles, like how we're going to make the supply chain work here?
Yeah.
And then the cost of materials, things like that, or is that too much?
Exactly. So, like another, like a good example, I think, of thinking about things in the limit is if you take any product, any machine or whatever, like take a rocket or whatever, and say, if you look at the raw materials in the rocket, so you're going to have like aluminum, steel, titanium, Inconel, specialty alloys, copper, and you say, what's the weight of the constituent elements of each of these elements, and what is their raw material value? And that sets the asymptotic limit for how low the cost of the vehicle can be unless you change the materials. So, and then when you do that, call it like maybe the magic wand number or something like that. So that would be like if you had like just a pile of these raw materials here, and you could wave the magic wand and rearrange the atoms into the final shape. That would be the lowest possible cost that you could make this thing for unless you change the materials. So then, and that is always almost always a very low number. So then what's actually causing things to be expensive is how you put the atoms into the desired shape.
Yeah, actually, if you don't mind me taking a tiny tangent, I often talk to Jim Keller, who's somebody that worked with you as a friend.
Yeah, Jim was did great work at Tesla.
So I suppose he carries the flame of the same kind of thinking that you're talking about now. And I guess I see that same thing at Tesla and SpaceX folks who work there. They kind of learn this way of thinking, and it kind of becomes obvious almost. But anyway, I had he educated me about how cheap it might be to manufacture a Tesla bot. We had an argument. How can you reduce the cost of scale of producing a robot? Because I gotten a chance to interact quite a bit, obviously in the academic circles with humanoid robots and then Boston Dynamics and stuff like that. And they're very expensive to build. Mm-hmm. And then Jim kind of schooled me on saying like, okay, like this kind of first principles thinking of how can we get the cost of manufacture down. I suppose you do that. You have done that kind of thinking for Tesla bot and for all kinds of complex systems that are traditionally seen as complex. And you say, okay, how can we simplify everything down?
Yeah. I mean, I think if you are really good at manufacturing, you can basically at high volume, you can basically make anything for a cost that asymptotically approaches the raw material value of the constituents plus any intellectual property that you need to license.
Right.
Anything.
Right.
But it's hard. It's not like that's a very hard thing to do, but it is possible for anything. Anything in volume can be made, like I said, for a cost that asymptotically approaches its raw material constituents plus intellectual property license rights. So what will often happen in trying to design a product is people will start with the tools and parts and methods that they are familiar with, and then try to create a product using their existing tools and methods. The other way to think about it is actually try to imagine the platonic ideal of the perfect product or technology, whatever it might be, and say what is the perfect arrangement of atoms that would be the best possible product. And now let us try to figure out how to get the atoms in that shape.
I mean, it sounds it's almost like Rick and Morty absurd until you start to really think about it, and you really should think about it in this way, because everything else is kind of if you think you might fall victim to the momentum of the way things were done in the past unless you think in this way.
Well, just as a function of inertia, people will want to use the same tools and methods that they are familiar with. That's what they'll do by default.
Yeah.
And then that will lead to an outcome of things that can be made with those tools and methods, but is unlikely to be the Platonic ideal of the perfect product. So that's why it's good to think of things in both directions. So like, what can we build with the tools that we have? But also, what is the theoretical perfect product look like? And that theoretical perfect product is going to be a moving target, because as you learn more, the definition of for that perfect product will change, because you don't actually know what the perfect product is, but you can successfully approximate a more perfect product. So thinking about it like that, and then saying, okay, now what tools, methods, materials, whatever, do we need to create in order to get the atoms in that shape? But people rarely think about it that way. But it's a powerful tool.
I should mention that the brilliant Siobhan Zillis is hanging out with us, in case you hear a voice of wisdom from outside, from up above. Okay, so let me ask you about Mars. You mentioned it would be great for science to put a base on the moon to do some research, but the truly big leap, again in this category of seemingly impossible, is to put a human being on Mars. When do you think SpaceX will land a human being on Mars?
Best case is about 5 years. Worst case, 10 years.
What are the determining factors, would you say, from an engineering perspective, or is that not the bottlenecks?
It's fundamentally, engineering the vehicle. Starship is the most complex and advanced rocket that's ever been made by, I don't know, order of magnitude or something like that. It's a lot. It's really next level. So, and the fundamental optimization of Starship is minimizing cost per ton to orbit and ultimately cost per ton to the surface of Mars. This may seem like a mercantile objective, but it is actually the thing that needs to be optimized. Like there is a certain cost per ton to the surface of Mars where we can afford to establish a self-sustaining city. And then above that, we cannot afford to do it. So right now, you couldn't fly to Mars for $1 trillion. No amount of money could get you a ticket to Mars. So we need to get that above, to get that like something that is actually possible at all. But that's we don't just want to have, with Mars flags and footprints and then not come back for a half century like we did with the moon. In order to pass a very important great filter, I think we need to be a multi-planet species. This may sound somewhat esoteric to a lot of people, but eventually, given enough time, the Earth is likely to experience some calamity. That could be something that humans do to themselves, or an external event like happened to the dinosaurs. But eventually, and if none of that happens, and somehow magically we keep going, then the sun is gradually expanding, and will engulf the Earth, and probably Earth gets too hot for life in about 500 million years. It's a long time, but that's only 10% longer than Earth has been around. And so if you think about like the current situation, it's really remarkable and kind of hard to believe, but Earth's been around 4.5 billion years, and this is the first time in 4.5 billion years that it's been possible to extend life beyond Earth. And that window of opportunity may be open for a long time, and I hope it is, but it also may be open for a short time. And we should, I think it was wise for us to act quickly while the window is open, just in case it closes.
Yeah, the existence of nuclear weapons, pandemics, all kinds of threats.
Yeah,
should kind of give us some motivation.
I mean, civilization could die with a bang or a whimper. You know, if it dies of demographic collapse, then it's more of a whimper, obviously. And if it's World War III, it's more of a bang. But these are all risks. I mean, it's important to think of these things and just, think of things as like probabilities, not certainties. There's a certain probability that something bad will happen on Earth. I think most likely the future will be good. But there's let's say for argument's sake, a 1% chance per century of a civilization ending event. Like that was Stephen Hawking's estimate. I think he might be right about that. So then, we should basically think of this like being a multi-planet species is like taking out insurance for life itself, like life insurance for life.
Wow,
so
it's turned into an infomercial real quick.
Life insurance for life, yes. And we can bring the creatures from plants and animals from Earth to Mars and breathe life into the planet, and have a second planet with life. That would be great. They can't bring themselves there, so if we don't bring them to Mars, then they will just for sure all die when the sun expands anyway, and then that'll be it.
What do you think is the most difficult aspect of building a civilization on Mars, terraforming Mars, like from an engineering perspective, from a financial perspective, human perspective, to get a large number of folks there who will never return back to Earth?
No, they could certainly return. Some will return back to Earth.
They will choose to stay there for the rest of their lives.
Yeah, many will. But we need the spaceships back, like the ones that go to Mars. Right. We need them back, so you can hop on if you want. Yeah. It's like, but we can't just not have the spaceships come back. Those things are expensive. We need them back. I'd like to come back and do another trip.
I mean, do you think about the terraforming aspect, like actually building? Are you so focused right now on the spaceships part that's so critical to get to Mars?
We absolutely. If you can't get there, nothing else matters. Yeah. So, and like I said, we can't get there at some extraordinarily high cost. I mean, the current cost of, let's say, 1 ton to the surface of Mars is on the order of $1 billion. So, because you don't just need the rocket and the launch and everything, you need like heat shield, you need, guidance system, you need deep space communications, you need some kind of landing system. So, like rough approximation would be $1 billion per ton to the surface of Mars right now. This is obviously way too expensive to create a self-sustaining civilization. So we need to improve that by at least a factor of 1,000.
$1 million per ton?
Yes, ideally much less than $1 million a ton. But if it's not, like, it's got to be. You have to say, like, well, how much can society afford to spend or want to spend on a self-sustaining city on Mars? The self-sustaining part is important. Like, it's just the key threshold. The great filter will have been passed when the city on Mars can survive even if the spaceships from Earth stop coming for any reason. It doesn't matter what the reason is, but if they stop coming for any reason, will it die out or will it not? And if there's even one critical ingredient missing, then it still doesn't count. It's like, if you're on a long sea voyage and you've got everything except vitamin C, it's only a matter of time, you're going to die. So we got to get a Mars city to the point where it's self-sustaining. I'm not sure this will really happen in my lifetime, but I hope to see it at least have a lot of momentum. And then you could say, okay, what is the minimum tonnage necessary to have a self-sustaining city? And there's a lot of uncertainty about this. So you could say, like, I don't know, it's probably at least 1 million tons, because you have to set up a lot of infrastructure on Mars. Like I said, you can't be missing anything that, in order to be self-sustaining, you can't be missing. Like, you need, semiconductor fabs, you need iron ore refineries, you need lots of things, and Mars is not super hospitable. It's the least inhospitable planet, but it's definitely a fixer-upper of a planet.
Outside of Earth.
Yes.
Earth is pretty
Earth
good.
Earth is like easy. Yeah.
And also we should clarify, in the solar system.
Yes, in the solar system.
There might be nice, like, vacation spots.
There might be some great planets out there, but it's hopeless.
Too hard to get there?
Yeah, way too hard, to say the least.
Let me push back on that. Not really a pushback, but a quick curveball of a question. So you did mention physics as the first starting point. So general relativity allows for wormholes. They technically can exist. Do you think those can ever be leveraged by humans to travel faster than the speed of light?
Well,
or are you saying
the wormhole thing is debatable. We currently do not know of any means of going faster than the speed of light. There is there are some ideas about having space, so you're going to move at the speed of light through space, but if you can make space itself move, that's warping space. Space is capable of moving faster than the speed of light.
Right.
Like the universe in the Big Bang, the universe expanded at much more than the speed of light, by a lot.
Yeah.
But if this is possible, the amount of energy required to warp space is so gigantic, it boggles the mind.
So all the work you've done with propulsion, how much innovation is possible with rocket propulsion? Is this, you've seen it all, and you're constantly innovating in every aspect. How much is possible? Like, how much can you get 10x somehow? Is there something in there in physics that you can get significant improvement in terms of efficiency of engines and all those kinds of things?
Well, as I was saying, like really the Holy Grail is a fully and rapidly reusable orbital system. So right now, the Falcon 9 is the only reusable rocket out there. But the booster comes back and lands. You've seen the videos, and we get the nose cone or fairing back, but we do not get the upper stage back. So that means that we have a minimum cost of building an upper stage. You can think of like a two-stage rocket of sort of like two airplanes, like a big airplane and a smaller airplane. And we get the big airplane back, but not the smaller airplane. And so it still costs a lot, so that upper stage is, at least $10 million. And then the degree of the booster is not as rapidly and completely reusable as we'd like, nor are the fairings. So, our kind of minimum marginal cost, not counting overhead per flight, is on the order of $15 to $20 million, maybe. That's extremely good it's by far better than any rocket ever in history. But with full and rapid reusability, we can reduce the cost per ton to orbit by a factor of 100. But just think of it like imagine if you had an aircraft or something, or a car, and if you had to buy a new car every time you went for a drive, it would be very expensive. It would be silly, frankly. Mm-hmm. But you just refuel the car or recharge the car, and that's makes your trip like 1,000 times cheaper. So it's the same for rockets. It's very difficult to make this complex machine that can go to orbit. And so if you cannot reuse it and have to throw even any significant part of it away, that massively increases the cost. So, Starship in theory could do a cost per launch of like $1 million, maybe $2 million or something like that. And put over 100 tons in orbit, which is crazy.
Yeah.
So
that's incredible. So you're saying like it's by far the biggest bang for the buck is to make it fully reusable versus like some kind of brilliant breakthrough in theoretical physics.
Yeah, no, there's no brilliant break. No, there's no. You're going to make the rocket reusable. This is an extremely difficult engineering problem.
Got it.
But no new physics is required.
Just brilliant engineering. Let me ask a slightly philosophical, fun question. Gotta ask. I know you're focused on getting to Mars, but once we're there on Mars, what form of government, economic system, political system do you think would work best for an early civilization of humans? The interesting reason to talk about this stuff, it also helps people dream about the future. I know you're really focused about the short-term engineering dream, but it's like, I don't know, there's something about imagining an actual civilization on Mars that really gives people hope.
Well, it would be a new frontier and an opportunity to rethink the whole nature of government, just as was done in the creation of the United States. So, I would suggest having direct democracy, like people vote directly on things as opposed to representative democracy. So representative democracy, I think, is too subject to special interests and, a coercion of the politicians and that kind of thing. So I'd recommend that there's just direct democracy. People vote on laws. The population votes on laws themselves, and then the laws must be short enough that people can understand them.
Yeah, and then like keeping a well-informed populace, like really being transparent about all the information about what they're voting for.
Absolute transparency.
Yeah, and not make it as annoying as those cookies where you have to accept the
cookies. Like always, there's like always like a slight amount of trepidation when you click accept cookies. Like I feel as though there's like perhaps like a very tiny chance that'll open a portal to hell or something like that.
That's exactly how I feel.
Why do they keep wanting me to accept it? What do they want with this cookie? Like somebody got upset with accepting cookies or something somewhere. Who cares? Like it's so annoying to keep accepting all these cookies.
To me, this is just a great.
Yes, you can have my damn cookie. I don't care. Whatever.
You heard it from Elon first. He accepts all of your damn cookies.
Yeah. And stop asking me. It's annoying.
Yeah, it's one example of implementation of a good idea done really horribly.
Yeah, it's somebody who was like, there's some good intentions of like privacy or whatever, but now everyone just has to click accept cookies, and it's now, you have billions of people who have to keep clicking accept cookie. It's super annoying. Then we just accept the damn cookie. It's fine. There is like, I think a fundamental problem that because we've not really had a major, like a world war or something like that in a while, and obviously we would like to not have world wars. There's not been a cleansing function for rules and regulations. So wars did have, some silver lining in that there would be a reset on rules and regulations after a war. So World Wars I and II, there were huge resets on rules and regulations. Now, if the society does not have a war and there's no cleansing function or garbage collection for rules and regulations, then rules and regulations will accumulate every year because they're immortal. There's no actual humans die, but the laws don't. So we need a garbage collection function for rules and regulations. They should not just be immortal, because some of the rules and regulations that are put in place will be counterproductive. Done with good intentions, but counterproductive. Sometimes not done with good intentions. So if rules and regulations just accumulate every year, and you get more and more of them, then eventually you won't be able to do anything. You're just like Gulliver with, tied down by thousands of little strings. And we see that in U.S. and like basically all economies that have been around for a while, and regulators and legislators create new rules and regulations every year. but they don't put effort into removing them. And I think that's very important that we put effort into removing rules and regulations. But it gets tough because you get special interests that then are dependent on, like they have a vested interest in that whatever rule and regulation, and that they fight to not get it removed.
Yeah, so I guess the problem with the Constitution is it's kind of like C versus Java, because it doesn't have any garbage collection built in. I think there should be. When you first said the metaphor of garbage collection, I loved
from
it.
a coding standpoint.
From a coding standpoint, yeah. It would be interesting if the laws themselves kind of had a built-in thing where they kind of die after a while unless somebody explicitly publicly defends them.
Yeah.
So that's sort of, it's not like somebody has to kill them; they kind of die themselves. They disappear.
Yeah.
Not to defend Java or anything, but C++, you could also have great garbage collection in Python and so on.
Yeah. So something needs to happen, or just the civilization's arteries just harden over time, and you can just get less and less done because there's just a rule against everything. So I think, like, I don't know, for Mars or whatever, I'd say, or even for, obviously for Earth as well, like, I think there should be an active process for removing rules and regulations and questioning their existence. Just like if we've got a function for creating rules and regulations, because rules and regulations you can also think of as like they're like software or lines of code for operating civilization. That's the rules and regulations. So it's not like we shouldn't have rules and regulations, but you have code accumulation, but no code removal, and so it just gets to become basically archaic bloatware after a while, and it's just it makes it hard for things to progress. So I don't know, maybe Mars, you'd have like any given law must have a sunset, and require active voting to keep it up there, And I actually also say, like, and these are just, I don't know, recommendations or thoughts, and ultimately it will be up to the people on Mars to decide. But I think it should be easier to remove a law than to add one, because of just to overcome the inertia of laws. So maybe it's like, for argument's sake, you need, like, say 60% vote to have a law take effect, but only a 40% vote to remove it.
So let me be the guy. You posted a meme on Twitter recently where there's like a row of urinals. A guy just walks all the way across.
Oh, sure, yeah.
And he tells you about crypto.
I mean, that's happened to be so many times. I think maybe even literally.
Yeah. Do you think, technologically speaking, there's any room for ideas of smart contracts or so on? Because you mentioned laws. That's an interesting use of things like smart contracts to implement the laws by which governments function. Like something built on Ethereum, or maybe a dog coin that enables smart contracts somehow.
I don't quite understand this whole smart contract thing. I mean,
so
I'm too dumb to understand smart contracts.
That's a good line.
I mean, my general approach to any kind of like deal or whatever is just make sure there's clarity of understanding. That's the most important thing.
Right.
And just keep any kind of deal very, very short and simple, plain language, and just make sure everyone understands this is the deal. Is it clear? And what are the consequences if various things don't happen? But usually deals are, business deals or whatever are way too long and complex and overly lawyered and pointlessly.
You mentioned that Doge is the people's coin.
Yeah.
And you said that you were literally SpaceX may consider literally putting a Doge coin on the moon. Is this something you're still considering? Mars, perhaps? Do you think there's some chance, we've talked about political systems on Mars, that Dogecoin is the official currency of Mars at some point in the future?
Well, I think Mars itself will need to have a different currency because you can't synchronize due to speed of light. Or not easily.
So it must be completely standalone from Earth.
Well, yeah, because the Mars is at closest approach, it's 4 light minutes away roughly, and then at furthest approach, it's roughly 20 light minutes away, maybe a little more. So you can't really have something synchronizing. If you've got a 20-minute speed of light issue, if it's got a 1-minute blockchain, it's not going to synchronize properly. So Mars would. I don't know if Mars would have a cryptocurrency as a thing, but probably seems likely. But it would be some kind of localized thing on Mars.
And you let the people decide.
Yeah, absolutely. The future of Mars should be up to the Martians. Yeah, so I think the cryptocurrency thing is an interesting approach to reducing the error in the database that is called money. I think I have a pretty deep understanding of what money actually is on a practical day-to-day basis because of PayPal. We really got in deep there. And right now, the money system, actually, for practical purposes, is really a bunch of heterogeneous mainframes running old COBOL.
Okay, you mean literally? That's
literally.
That's literally what's happening
in batch mode. Okay.
In batch mode.
Yeah, I pity the poor bastards who have to maintain that code. Okay, that's a pain. That's pain.
Not even Fortran. It's COBOL. Yep,
it's COBOL. And the banks are still buying mainframes in 2021 and running ancient COBOL code. The Federal Reserve is probably even older than what the banks have, and they have an old COBOL mainframe. And so now, so the government effectively has editing privileges on the money database, and they use those editing privileges to make more money whenever they want, and this increases the error in the database that is money. So I think money should really be viewed through the lens of information theory, and so it's kind of like an internet connection. Like, what's the bandwidth? Total bit rate. What is the latency, jitter, packet drop? Errors in the network communication. Just think of money like that, basically. I think that's probably the right way to think of it, and then say what system, from an information theory standpoint, allows an economy to function the best. Crypto is an attempt to reduce the error in money that is contributed by governments diluting the money supply as basically a pernicious form of taxation.
So both policy in terms of with inflation and actual technological cobalt, cryptocurrency takes us into the 21st century in terms of the actual systems that allow you to do the transaction, to store wealth, all those kinds of things.
Like I said, just think of money as information. People often will think of money as having power in and of itself. It does not. Money is information, and it does not have power in and of itself. Again, applying the physics tools of thinking about things in the limit is helpful. If you are stranded on a tropical island and you have $1 trillion, it's useless because there's no resource allocation. Money is a database for resource allocation, but there's no resources to allocate except yourself. So money is useless. If you're stranded on a desert island with no food, all the Bitcoin in the world will not stop you from starving.
Yeah.
So, just think of money as a database for resource allocation across time and space, and then what system it is in what form should that database or data system what would be most effective. Now, there is a fundamental issue with, say, Bitcoin in its current form, in that the transaction volume is very limited, and the latency, the latency for a properly confirmed transaction is too long, much longer than you'd like. So it's actually not great from a transaction volume standpoint or a latency standpoint. So it is perhaps useful as to solve an aspect of the money database problem, which is this sort of store of wealth or an accounting of relative obligations, I suppose. But it is not useful as a currency, as a day-to-day currency.
But people have proposed different technological solutions,
like Lightning.
Lightning Network and the layer 2 technologies on top of that. I mean, it seems to be all kind of a trade-off. But the point is, it's kind of brilliant to say that just think about information, think about what kind of database, what kind of infrastructure enables that exchange of information.
You're operating an economy, and you need to have something that allows for the to have efficient value ratios between products and services. So you got this massive number of products and services, and you can't just barter. It's like that would be extremely unwieldy. So you need something that gives you a ratio of exchange between goods and services, and then something that allows you to shift obligations across time, like debt and equity, shift obligations across time. Then what does the best job of that? Part of the reason why I think there's some merit to Dogecoin, even though it was obviously created as a joke, is that it actually does have a much higher transaction volume capability than Bitcoin, and the cost of doing a transaction, the Dogecoin fee is very low. Like right now, if you want to do a Bitcoin transaction, the price of doing that transaction is very high, so you could not use it effectively for most things, and nor could it even scale to a high volume. And when Bitcoin was started, I guess around 2008 or something like that, the internet connections were much worse than they are today, like order of magnitude. They're way worse, in 2008. So like having a small block size or whatever is, and a long synchronization time made sense in 2008. But to 2021 or fast forward 10 years, it's like comically low. And I think there's some value to having a linear increase in the amount of currency that is generated. So because some amount of the currency, if a currency is too deflationary, or should say if a currency is expected to increase in value over time, there's reluctance to spend it, because you're like, I'll just hold it and not spend it because its scarcity is increasing with time. So if I spend it now, then I will regret spending it. So I will just hodl it. Mm-hmm. But if there's some dilution of the currency occurring over time, that's more of an incentive to use it as a currency. So Dogecoin, somewhat randomly, has just a fixed number of sort of coins or hash strings that are generated every year. So there's some inflation, but it's not a percentage base. It's a fixed number. So the percentage of inflation will necessarily decline over time. So I'm not saying that it's like the ideal system for a currency, but I think it actually is just fundamentally better than anything else I've seen, just by accident. So
I like how you said around 2008. So you're not, some people suggested you might be Satoshi Nakamoto. You've previously said you're not. Let me ask. Not. You're not, for sure. Would you tell us if you were?
Yes.
Okay. Do you think it's a feature or bug that he's anonymous, or she or they? It's an interesting kind of quirk of human history that there is a particular technology that is a completely anonymous inventor or creator.
Well, I mean, you can look at the evolution of ideas before the launch of Bitcoin and see who wrote, about those ideas. And then I don't know exactly, obviously I don't know who created Bitcoin for practical purposes, but the evolution of ideas is pretty clear before that. And like, it seems as though like Nick Szabo is probably more than anyone else responsible for the evolution of those ideas. So, he claims not to be Nakamoto, but I'm not sure that's neither here nor there. But he seems to be the one more responsible for the ideas behind Bitcoin than anyone else.
So it's not perhaps like singular figures aren't even as important as the figures involved in the evolution of ideas that led to a thing. So yeah, it's perhaps it's sad to think about history, but maybe most names would be forgotten anyway.
What is a name anyway? It's a name attached to an idea. What does it even mean, really?
I think Shakespeare had a thing about roses and stuff, whatever he said.
Rose by any other name would smell sweet.
I got Elon to quote Shakespeare. I feel like I accomplished something today.
Shall I compare thee to a summer's day?
I'm gonna clip that out.
Not more temperate and more fair.
Autopilot. Tesla Autopilot. Tesla Autopilot has been through an incredible journey over the past 6 years, or perhaps even longer in your mind, in the minds of many involved.
I think that's where we first connected. Really, was the autopilot stuff, autonomy, and
the whole journey was incredible to me to watch. I was because I knew. Well, part of it is I was at MIT and I knew the difficulty of computer vision.
Yeah.
And I knew I had a lot of colleagues and friends about the DARPA challenge. I knew how difficult it is. Mm-hmm. And so there was a natural skepticism. When I first drove a Tesla with the initial system based on Mobileye, I thought there's no way. So first when I got in, I thought there's no way this car could maintain stay in the lane and create a comfortable experience. So my intuition initially was that the lane keeping problem is way too difficult to solve.
Oh, lane keeping, that's relatively easy.
No, but solve in the way that we talked about previous is prototype versus a thing that actually creates a pleasant experience over hundreds of thousands of miles and millions. So I was proven wrong.
We had to wrap a lot of code around the Mobileye thing. It didn't just work by itself.
Yes, I mean that's part of the story of how you approach things. Sometimes you do things from scratch. Sometimes at first you kind of see what's out there, and then you decide to do from scratch. That was one of the boldest decisions I've seen, is both on the hardware and the software, to decide to eventually go from scratch. I thought, again, I was skeptical of whether that's going to be able to work out, because it's such a difficult problem. And so it was an incredible journey. What I see now with everything, the hardware, the compute, the sensors, the things I maybe care and love about most is the stuff that Andrej Karpathy is leading with the data set selection, the whole data engine process, the neural network architectures, the way that's in the real world that network is tested, validated, all the different test sets, versus the ImageNet model of computer vision, like what's in academia is like real world artificial intelligence. Yeah. So,
and Andrej's awesome and obviously plays an important role, but we have a lot of really talented people driving things. So, and Ashok is actually the head of autopilot engineering. Andrej's director of AI
stuff. Yeah. So I'm aware that there's an incredible team of just a lot going on.
Yeah, just obviously people will give me too much credit, and they'll give Andrej too much credit. So,
and people should realize how much is going on under the hood.
It's just a lot of really talented people. The Tesla Autopilot AI team is extremely talented. It's like some of the smartest people in the world. So yeah, we're getting it done.
What are some insights you've gained over those 5-6 years of autopilot about the problem of autonomous driving? So you leaped in having some sort of first principles kinds of intuitions, but nobody knows how difficult the problem. I
thought the self-driving problem would be hard, but it was harder than I thought. It's not like I thought it would be easy. I thought it would be very hard, but it was actually way harder than even that. So, I mean, what it comes down to at the end of the day is to solve self-driving, you have to solve. You basically need to recreate what humans do to drive, which is humans drive with optical senses, eyes, and biological neural nets. And so, in order to that's how the entire road system is designed to work with basically passive optical and neural nets, biologically. And now that we need to, so for full self-driving to work, we have to recreate that in digital form. So we have to, that means cameras with advanced neural nets in silicon form, and then it will obviously solve for full self-driving. That's the only way. I don't think there's any other way.
But the question is, what aspects of human nature do you have to encode into the machine, right? So you have to solve the perception problem, like detect, and then you first realize what is the perception problem for driving, like all the kinds of things you have to be able to see. Like what do we even look at when we drive? There's I just recently heard Andre talked about at MIT about like car doors. I think it was the world's greatest talk of all time about car doors.
Yeah.
The fine details of car doors. Like what is even an open car door, man? So like the ontology of that's the perception problem. We humans solve that perception problem, and Tesla has to solve that problem. And then there's the control and the planning coupled with the perception. You have to figure out like what's involved in driving, like especially in all the different edge cases. And then I mean, maybe you can comment on this. How much game theoretic kind of stuff needs to be involved, at a 4-way stop sign? As humans, when we drive, our actions affect the world. Like,
sure,
it changes how others behave. Most autonomous driving, you're usually just responding to the scene, as opposed to like really asserting yourself in the scene. Do you think?
I think these sort of control logic conundrums are not the hard part. Let's see.
What do you think is the hard part in this whole beautiful, complex problem?
So it's a lot of friggin' software, man. A lot of smart lines of code. For sure, in order to have create an accurate vector space. So, like if you're coming from image space, which is like this flow of photons, going to the cameras, and and then so you have this massive bit stream in image space, and then you have to effectively compress a massive bit stream corresponding to photons that knocked off an electron in a camera sensor, and turn that bit stream into vector space. By vector space, I mean like you've got cars and humans and lane lines and curves and traffic lights and that kind of thing. Once you have an accurate vector space, the control problem is similar to that of a video game, like a Grand Theft Auto or Cyberpunk. If you have accurate vector space, it's the control problem is I wouldn't say it's trivial. It's not trivial, but it's like it's not like some insurmountable thing. But having an accurate vector space is very difficult.
Yeah, I think we humans don't give enough respect to how incredible the human perception system is, to mapping the raw photons to the vector space representation in our heads.
Your brain is doing an incredible amount of processing, and giving you an image that is a very cleaned up image. Like when we look around here, we see, like you see color in the corners of your eyes, but actually your eyes have very few cones, like cone receptors in the peripheral vision. Your eyes are painting color in the peripheral vision. You don't realize it, but their eyes are actually painting color, and your eyes also have like this blood vessels and all sorts of gnarly things, and there's a blind spot. But do you see your blind spot? No, your brain is painting in the blind spot. And you're going to do these see these things online where you look here and look at this point, and then look at this point, and if it's in your blind spot, your brain will just fill in the missing bits.
So cool. The peripheral vision is so cool. It
Yeah.
makes you realize all the illusions for vision science. It makes you realize just how incredible the brain is.
The brain is doing a crazy amount of post-processing on the vision signals from your eyes. It's insane. So, and then even once you get all those vision signals, your brain is constantly trying to forget as much as possible. So human memory is perhaps the weakest thing about the brain is memory. So because memory is so expensive to a brain and so limited, your brain is trying to forget as much as possible and distill the things that you see into the smallest amounts of information possible. So your brain is trying to not just get to a vector space, but get to a vector space that is the smallest possible vector space of only relevant objects. And I think you can sort of look inside your brain, or at least I can, like when you drive down the road and try to think about what your brain is actually doing consciously. And it's like you'll see a car because you don't have cameras, you don't have eyes in the back of your head or the side, so you say like you basically your head is like you basically have like two cameras on a slow gimbal. And what's your and eyesight's not that great. Okay, human eyes are, and people are constantly distracted and thinking about things and texting and doing all sorts of things they shouldn't do in a car, changing the radio station. So having arguments, is like so then like say like when's the last time you looked right and left and and rearward, or even diagonally forward, to actually refresh your vector space. So you're glancing around, and what your mind is doing is trying to distill the relevant vectors, basically objects with a position and motion, and then editing that down to the least amount that's necessary for you to drive.
It does seem to be able to edit it down or compress it even further into things like concepts. So it's like it goes beyond, the human mind seems to go sometimes beyond vector space to sort of space of concepts, to where you'll see a thing, it's no longer represented spatially somehow. It's almost like a concept that you should be aware of. Like if this is a school zone, you'll remember that as a concept, which is a weird thing to represent. But perhaps for driving, you don't need to fully represent those things, or maybe you get those kind of indirectly.
You need to like establish vector space and then actually have predictions for those vector spaces. So like like if like you drive past say a bus and you see that there's people. Before you drove past the bus, you saw people crossing, just imagine there's like a large truck or something blocking sight. But before you came up to the truck, you saw that there were some kids about to cross the road in front of the truck. Now you can no longer see the kids, but you need to be able. But you would now know, okay, those kids are probably going to pass by the truck and cross the road, even though you cannot see them. So you have to have memory. You need to remember that there were kids there, and you need to have some forward prediction of what their position will be
It's a really hard
at
problem.
the time of relevance.
So with occlusions and computer vision, when you can't see an object anymore, even when it just walks behind a tree and reappears, that's a really, really, I mean, at least in academic literature, it's tracking through occlusions. It's very difficult.
Yeah, we're doing it.
I understand this.
Yeah.
So some of it,
It's like object permanence. Like the same thing happens with the humans with neural nets. Like when like a toddler grows up, like there's a point in time where they have a sense of object permanence. So before a certain age, if you have a ball or a toy or whatever, and you put it behind your back and you pop it out, if they don't, before they have object permanence, it's like a new thing every time. It's like, whoa, this toy went poof, disappeared, and now it's back again, and they can't believe it. And that they can play peekaboo all day long because the peekaboo is fresh every time. But then we figure out object permanence. Then they realize, oh no, the object is not gone; it's just behind your back.
sometimes I wish we never did figure out object permanence.
Yeah, so that's
So that's an important problem to solve.
yes. So like an important evolution of the neural nets in the car is memory across both time and space. So now you can't remember. Like you have to say, like, how long do you want to remember things for? And there's a cost to remembering things for a long time. So you know, like run out of memory if you try to remember too much for too long. And then you also have things that are stale if you remember them for too long. And then you also need things that are remembered over time. So even if you, like, say, have, like, for argument's sake, 5 seconds of memory on a time basis, but, like, let's say you're parked at a light and you saw, use a pedestrian example, that people were waiting to cross the road, and you can't quite see them because of an occlusion. But they might wait for a minute before the light changes for them to cross the road. You still need to remember that that's where they were, and that they're probably going to cross the road, type of thing. So even if that exceeds your time-based memory, it should not exceed your space memory.
And I just think the data engine side of that, so getting the data to learn all of the concepts that you're saying now, is an incredible process. It's this iterative process of just, it's this HydroNet of many...
HydroNet.
Yeah.
We're changing the name to something else.
Okay. I'm sure it'll be equally as Rick and Morty like.
There's a lot of... We've re-architected the neural net, neural nets in the cars so many times. It's crazy.
Oh, so every time there's a new major version, you'll rename it to something more ridiculous or memorable and beautiful. Sorry, not ridiculous, of course.
If you see the full like array of neural nets that are operating in the car, it kind of boggles the mind. There's so many layers. It's crazy. So yeah, but we started off with simple neural nets that were basically image recognition on a single frame from a single camera, and then trying to knit those together with C. I should say we're really primarily running C here because C++ is too much overhead, and we have our own C compiler. So to get maximum performance, we actually wrote our own C compiler and are continuing to optimize our C compiler for maximum efficiency. In fact, we've just recently done a new rev on a C compiler that'll compile directly to our autopilot hardware.
So you want to compile the whole thing down and with your own compiler.
Yeah.
Like, so efficiency absolutely. Here, because there's all kinds of compute. There's CPU, GPU, there's like ASIC types of things. And you have to somehow figure out the scheduling across all of those things. And so you're compiling the code down that does all, okay. So that's why there's a lot of people involved.
There's a lot of hardcore software engineering at a very sort of bare metal level, because we're trying to do a lot of compute that's constrained to our full self-driving computer. So, and we want to try to have the highest frames per second possible in a sort of very, very finite amount of compute and power. So we really put a lot of effort into the efficiency of our compute. So there's actually a lot of work done by some very talented software engineers at Tesla that at a very foundational level to improve the efficiency of compute and how we use the trip accelerators, which are basically doing matrix math dot products, like a bazillion dot products. And it's like what are neural nets? It's like compute wise, like 99% dot products. So,
and you want to achieve as many high frame rates, like a video game. You want full resolution, high frame rate,
low latency, low jitter. I think one of the things we're moving towards now is no post-processing of the image through the image signal processor. So, like for what happens for cameras is that almost all cameras is there's a lot of post-processing done in order to make pictures look pretty. Mm-hmm. And so we don't care about pictures looking pretty. We just want the data. So we're moving to just raw photon counts. So the system will, like the image that the computer sees is actually much more than what you'd see if you represented it on a camera. It's got much more data. And even in very low light conditions, you can see that there's a small photon count difference between, this spot here and that spot there, which means that, so it can see in the dark incredibly well, because it can detect these tiny differences in photon counts. That's like much better than you could possibly imagine. So then we also save 13 milliseconds on latency.
From removing the post-processing on the image?
Yes. Yeah. It's like, because we've got, 8 cameras and then there's roughly, 1.5 milliseconds or so, maybe 1.6 milliseconds of latency for each camera. And so going to just basically bypassing the image processor gets us back 13 milliseconds of latency, which is important. And we track latency all the way from, photon hits the camera to, all the steps that it's got to go through to get, go through the various neural nets and the C code and there's a little bit of C++ there as well. Maybe a lot, but the core stuff is the heavy duty compute is all in C. And so we track that latency all the way to an output command to the drive unit to accelerate, the brakes to slow down, the steering, turn left or right. So because you got to output a command that's going to go to a controller, and like some of these controllers have an update frequency that's maybe 10 hertz or something like that, which is slow. That's like now you lose 100 milliseconds potentially. So then we want to update the drivers on the, like say, steering and braking control to have more like 100 hertz instead of 10 hertz. And you get a 10 milliseconds latency instead of 100 milliseconds worst case latency. And actually jitter is more of a challenge than latency, because latency is like you can anticipate and predict. But if you've got a stack up of things going from the camera to the computer through then a series of other computers and finally to an actuator on the car, if you have a stack up of tolerances, of timing tolerances, then you can have quite a variable latency, which is called jitter. And that makes it hard to anticipate exactly how you should turn the car or accelerate, because if you got maybe 150, 200 milliseconds of jitter, then you could be off by up to 0.2 seconds, and this could make a big difference.
So you have to interpolate somehow to deal with the effects of jitter, so that you can make like robust control decisions. You have to. So the jitter is in the sensor information, or the jitter can occur at any stage in the pipeline.
You can, if you have fixed latency, you can anticipate, and like say, okay, we know that our information is, for argument's sake, 150 milliseconds stale. Like so, for 150 for argument's sake, 150 milliseconds from photon-taking camera to where you can measure a change in the acceleration of the vehicle. So then you can say, okay, well, we're going to, we know it's 150 milliseconds, so we're going to take that into account and compensate for that latency. However, if you've got then 150 milliseconds of latency plus 100 milliseconds of jitter, which could be anywhere from 0 to 100 milliseconds on top. So then your latency could be from 150 to 250 milliseconds. Now you've got 100 milliseconds that you don't know what to do with. And that's basically random. So getting rid of jitter is extremely important.
And that affects your control decisions and all those kinds of things. Okay.
Yeah, the car is just going to fundamentally maneuver better with lower jitter.
Got it.
And the cars will maneuver with superhuman ability and reaction time much faster than a human. I mean, I think over time, the autopilot full self-driving will be capable of maneuvers that, are far more than what like James Bond could do in like the best movie type of thing.
That's exactly what I was imagining in my mind as you said it.
It's like impossible maneuvers that a human couldn't do, So,
well, let me ask, sort of looking back at the 6 years, looking out into the future, based on your current understanding, how hard do you think this full self-driving problem? When do you think Tesla will solve level 4 FSD?
I mean, it's looking quite likely that it will be next year.
And what does the solution look like? Is it the current pool of FSD beta candidates, they start getting greater and greater as they have been degrees of autonomy, and then there's a certain level beyond which they can do their own, they can read a book?
Yeah. So, I mean, you can see that anybody who's been following the full self-driving beta closely will see that the rate of disengagements has been dropping rapidly. So, like a disengagement be where the driver intervenes to prevent the car from doing something dangerous potentially. So, the interventions, per million miles has been dropping dramatically. At some point, and that trend looks like it happens next year, is that the probability of an accident on FSD is less than that of the average human, and then significantly less than that of the average human. So it certainly appears like we will get there next year. Then of course then there's going to be a case of, okay, well, we now have to prove this to regulators and prove it to and we want a standard that is not just equivalent to a human, but much better than the average human. I think it's got to be at least 2 or 3 times higher safety than a human. So 2 or 3 times lower probability of injury than a human. Before we would actually say like, okay, it's okay to go. It's not going to be equivalent. It's got to be much better.
So if you look, FSD 10.6 just came out recently. 10.7 is on the way. Maybe 11 is on the way somewhere in the future.
Yeah. We were hoping to get 11 out this year, but it's 11 actually has a whole bunch of fundamental rewrites on the neural net architecture, and some fundamental improvements in creating vector space. So
there is some fundamental leap that really deserves the 11. I mean, that's a pretty cool number.
Yeah. 11 would be a single stack for all, one stack to rule them all. But there are just some really fundamental neural net architecture changes that will allow for much more capability, but at first they're going to have issues. So, like, we have this working on sort of alpha software, and it's good, but it's basically taking a whole bunch of C code and deleting a massive amount of C++ code and replacing it with the neural net. And Andre makes this point a lot, which is like neural nets are kind of eating software. Over time, there's less and less conventional software, more and more neural net, which is still software, but it's still comes down to lines of software. But let's just more neural net stuff and less heuristics, basically. If you're more matrix based stuff and less heuristics based stuff. Like one of the big changes will be like right now the neural nets will deliver a giant bag of points to the C++ or C and C++ code.
Yeah.
We call it the giant bag of points.
Yeah.
And it's like, so you got a pixel and something associated with that pixel. Like this pixel is probably car. This pixel is probably lane line. Then you've got to assemble this giant bag of points in the C code and turn it into vectors. And it does a pretty good job of it, but we need another layer of neural nets on top of that to take the giant bag of points and distill that down to vector space in the neural net part of the software as opposed to the heuristics part of the software. This is a big improvement.
Neural nets all the way down is what you want.
It's not even all neural nets, but this will be just this is a game changer to not have the bag of points, the giant bag of points that has to be assembled with many lines of C++, and have a neural net just assemble those into a vector. So that the neural net is outputting much less data. It's outputting this is a lane line, this is a curb, this is drivable space, this is a car, this is a pedestrian or a cyclist or something like that. It's outputting it's really outputting proper vectors to the C++ control code, as opposed to the sort of constructing the vectors in C, which we've done, I think, quite a good job of. But we're kind of hitting a local maximum on how well the C can do this. So this is really a big deal. And just all of the networks in the car need to move to surround video. There's still some legacy networks that are not surround video. And all of the training needs to move to surround video. And the efficiency of the training needs to get better, and it is. And then we need to move everything to raw photon counts as opposed to processed images.
Okay, so
which is quite a big reset on the training, because the system's trained on post-processed images. So we need to redo all the training to train against the raw photon counts instead of the post-processed image.
So ultimately, it's kind of reducing the complexity of the whole thing. So reducing
lines of code will actually go lower.
Yeah, that's fascinating. So you're doing fusion of all the sensors, so reducing the complexity of having to deal with each
fusion
sensor.
Of the cameras is there's not like cameras, really.
Right. Yes.
Yeah.
Same with humans. Well, I guess we got ears too. Okay.
Yeah. We'll actually need to incorporate sound as well, because you need to like listen for ambulance sirens, or fire trucks. Or if somebody like yelling at you or something. I don't know. Just there's a little bit of audio that needs to be incorporated as well.
Do you need a quick bathroom break?
Yeah, let's take a break.
Okay.
Honestly, frankly, like the ideas are the easy thing, and the implementation is the hard thing. Like the idea of going to the moon is the easy part.
Yeah.
But going to the moon is the hard part.
It's the hard part.
And there's a lot of like hardcore engineering that's got to get done at the hardware and software level. Like I said, optimizing the C compiler and just cutting out latency everywhere. If we don't do this, the system will not work properly. So the work of the engineers doing this, they are like the unsung heroes to some, but they are critical to the success of the situation.
I think you made it clear. I mean, at least to me, it's super exciting. Everything that's going on outside of what Andre is doing.
Yeah,
just the whole infrastructure, the software. I mean, everything is going on with Data Engine, whatever it's called. The whole process is just
Yeah,
a work of art to me.
The sheer scale of it is boggles the mind. Like the training, the amount of work done with, like we've written all this custom software for training and labeling, and to do auto labeling. Auto labeling is essential, because especially when you've got like surround video, it's very difficult to like label surround video from scratch is extremely difficult. It like take a human such a long time to even label one video clip, like several hours. Or the auto labeler, basically we just apply a heavy duty, like a lot of compute to the video clips, to pre-assign and guess what all the things are that are going on in the surround video.
And then there's like correcting it.
Yeah, and then all the human has to do is like tweet, like say this, adjust what is incorrect. This is like increases productivity by 100 or more.
Yeah. So you've presented Tesla Bot as primarily useful in the factory. First of all, I think humanoid robots are incredible. From a fan of robotics, I think the elegance of movement that humanoid robots, the bipedal robots show are just so cool. So it's really interesting that you're working on this and also talking about applying the same kind of all the ideas of some of which we've talked about with data engine, all the things that we're talking about with Tesla Autopilot, just transferring that over to just yet another robotics problem. I have to ask, since I care about human-robot interaction, so the human side of that. So you've talked about mostly in the factory. Do you see it also? Do you see part of this problem that Tesla Bot has to solve is interacting with humans and potentially having a place like in the home? So interacting, not just not replacing labor, but also like, I don't know,
well, I think
being a friend or an assistant.
Yeah,
or something like that.
I think the possibilities are, endless. Yeah, I mean, it's obviously like it's not quite in Tesla's primary mission direction of accelerating sustainable energy, but it is an extremely useful thing that we can do for the world, which is to make a useful humanoid robot that is capable of interacting with the world and helping in many different ways. So in factories and really just I mean, I think if you say like extrapolate to many years in the future, it's like I think work will become optional. So like there's a lot of jobs that if people weren't paid to do it, they wouldn't do it. Like it's not fun, necessarily. Like if you're washing dishes all day, it's like even if you really like washing dishes, you really want to do it for 8 hours a day every day? Probably not. So and then there's like dangerous work, and basically if it's dangerous, boring, it has like potential for repetitive stress injury, that kind of thing, then that's really where humanoid robots would add the most value initially. So that's what we're aiming for is to for the humanoid robots to do jobs that people don't voluntarily want to do. And then we'll have to pair that obviously with some kind of universal basic income in the future. So I think.
So do you see a world when there's like hundreds of millions of Tesla bots performing different tasks throughout the world?
Yeah, I haven't really thought about it that far into the future, but I guess that there may be something like that. So,
Can I ask a wild question? So the number of Tesla cars has been accelerating. There's been close to 2 million produced. Many of them have autopilot.
I think we're over 2 million now. Yeah.
Do you think there will ever be a time when there will be more Tesla bots than Tesla cars?
Yeah, I actually, it's funny you asked this question because normally I do try to think pretty far into the future, but I haven't really thought that far into the future with the Tesla bot, or it's codenamed Optimus. I call it Optimus Subprime because it's not like a giant transformer robot. But it's meant to be a general purpose helper bot. And basically like the things that we're basically like Tesla I think, has the most advanced real-world AI for interacting with the real world, which we developed as a function of to make self-driving work. And so, along with custom hardware and like a lot of, hardcore low-level software to have it run efficiently and be, power efficient, because it's one thing to do neural nets if you've got a gigantic server room with 10,000 computers, but now let's say you have to now distill that down into one computer that's running at low power in a humanoid robot or a car. That's actually very difficult, and a lot of hardcore software work is required for that. So since we're kind of like solving the navigate the real world with neural nets problem for cars, which are kind of like robots with four wheels, then it's like kind of a natural extension of that is to put it in a robot with arms and legs, and actuators. Like the two like hard things are like you basically need to have the robot be intelligent enough to interact in a sensible way with the environment. So you need real world AI, and you need to be very good at manufacturing, which is a very hard problem. Tesla is very good at manufacturing, and also has the real world AI. So making the humanoid robot work is basically means developing custom motors and sensors that are different from what a car would use. But we have I think we have the best expertise in developing advanced electric motors and power electronics. So it just has to be for a humanoid robot application, not a car.
Still, you do talk about love sometimes. So let me ask, this isn't like for like sex robots or something like that.
Love is the answer.
Yes. There is something compelling to us, not compelling, but we connect with humanoid robots or even legged robots, like with the dog in shapes of dogs. It seems like, there's a huge amount of loneliness in this world. All of us seek companionship and with other humans, friendship, and all those kinds of things. We have a lot here in Austin. A lot of people have dogs.
Sure.
There seems to be a huge opportunity to also have robots that decrease the amount of loneliness in the world, or help us humans connect with each other. So in the way that dogs can. Do you think about that? Would test about it all, or is it really focused on the problem of performing specific tasks, not connecting with humans?
I mean, to be honest, I have not actually thought about it from the companionship standpoint, but I think it actually would end up being, it could be actually a very good companion. And it could, you develop like a personality over time that is like unique. Like, it's not like they're just all the robots are the same. And that personality could evolve to be, match the owner, or the, I guess the owner,
well,
whatever you want to call it,
the companion, the other half, right? In the same way that friends do. See, I think that's a huge opportunity. I think. Yeah,
no, that's interesting. Because like there's a Japanese phrase I like, the wabi-sabi. The subtle imperfections are what makes something special.
Yeah.
And the subtle imperfections of the personality of the robot mapped to the subtle imperfections of the robot's human friend. I don't know. Owner sounds like maybe the wrong word, but could actually make an incredible buddy, basically.
In that way, the imperfections,
like R2-D2 or like a C-3PO sort of thing,
So from a machine learning perspective, I think the flaws being a feature is really nice. You could be quite terrible at being a robot for quite a while in the general home environment or in the general world, and that's kind of adorable. And that's like, those are your flaws, and you fall in love with those flaws. So it's very different than autonomous driving, where it's a very high stakes environment you cannot mess up. And so it's more fun to be a robot in the home.
Yeah, in fact, if you think of like C-3PO and R2D2.
Yeah.
Like they actually had a lot of like flaws and imperfections and silly things, and they would argue with each other. And
were they actually good at doing anything? I'm not exactly sure.
They definitely added a lot to the story. But there's sort of quirky elements, and that they would like make mistakes and do things. Like it was like it made them relatable. I don't know, enduring. So yeah, I think that could be something that it probably would happen. But our initial focus is just to make it useful. I'm confident we'll get it done. I'm not sure what the exact time frame is, but like we'll probably have, I don't know, a decent prototype towards the end of next year or something like that.
And it's cool that it's connected to Tesla, the car. So like
it's using a lot of, it would use the autopilot inference computer and a lot of the training that we've done for cars in terms of recognizing real world things could be applied directly to the robot. But there's a lot of custom actuators and sensors that need to be developed.
Mm-hmm. And an extra module on top of the vector space for love.
Yeah,
that's me saying. Okay,
we could add that to the car too.
That's true. It could be useful in all environments. Like you said, a lot of people argue in the car, so maybe we can help them out. You're a student of history, fan of Dan Carlin's Hardcore History podcast.
Yeah, it's great.
Greatest podcast ever.
Yeah, I think it is actually.
It almost doesn't really count as a podcast.
Yeah, it's more like a audiobook.
Yeah. So you were on the podcast with Dan. I just had a chat with him about it. He said you guys went military and all that kind of stuff.
Yeah, it's literally. It was basically. I think it should be titled "Engineer Wars." Essentially, like when there's a rapid change in the rate of technology, then engineering plays a pivotal role in victory in battle.
How far back in history did you go? Did you go World War II?
It was mostly it was supposed to be a deep dive on fighters and bomber technology in World War II, but that ended up being more wide ranging than that. Because I just went down a total rat hole of like studying all of the fighters and bombers of World War II and like the constant rock paper scissors game that, like, one country would make this plane, then it'd make a plane to beat that, and that try to make a plane to beat that, and then and really what matters is like the pace of innovation, and also access to high quality fuel and raw materials. So like Germany had like some amazing designs, but they couldn't make them because they couldn't get the raw materials, and they had a real problem with oil and fuel. Basically, the fuel quality was extremely variable.
So the design wasn't the bottleneck. It was
like the U.S. had kick-ass fuel that was like very consistent. Like the problem is if you make a very high performance aircraft engine, in order to make it high performance, you have to the fuel, the aviation gas, has to be a consistent mixture, and it has to have a high octane. Like high octane is the most important thing, but also can't have like impurities and stuff because you'll foul up the engine. And Germany just never had good access to oil. Like they tried to get it by invading the Caucasus, but that didn't work too well.
That never works well.
Didn't work out for them. Nice to meet you. So Germany was always struggling with basically shitty oil, and so then they could not, they couldn't count on high quality fuel for their aircraft. So then they had to have all these additives and stuff. Whereas the U.S. had awesome fuel, and that provided that to Britain as well. So that allowed the British and the Americans to design aircraft engines that were super high performance, better than anything else in the world. And Germany could design the engines; they just didn't have the fuel, and then also the quality of the aluminum alloys that they were getting was also not that great. And so,
is this like you talked about all this with Dan?
Yep.
Awesome. Broadly looking at history, when you look at Genghis Khan, when you look at Stalin, Hitler, the darkest moments of human history. What do you take away from those moments? Does it help you gain insight about human nature, about human behavior today? Whether it's the wars or the individuals or just the behavior of people, any aspects of history?
Yeah, I find history fascinating. There's just a lot of incredible things that have been done, good and bad, that they help you understand the nature of civilization and individuals. And
does it make you sad that humans do these kinds of things to each other? You look at the 20th century, World War II, the cruelty, the abuse of power. Talk about communism, Marxism, and Stalin.
Some of these things do. If you like, there's a lot of human history. Most of it is actually people just getting on with their lives. And it's not like human history is just nonstop war and disaster. Those are actually just, those are intermittent and rare. And if they weren't, then humans would soon cease to exist. But it's just that wars tend to be written about a lot, and whereas like something being like, well, a normal year where nothing major happened doesn't get written about much. But that's, most people just like farming and kind of like living their life, being a villager somewhere. And every now and again there's a war, and I think so. But I would have to say, like, there aren't very many books that where I just had to stop reading because it was just too dark. But the book about Stalin, The Court of the Red Tsar, I had to stop reading. It was just too dark, rough.
Yeah. The 30s. There's a lot of lessons there to me, in particular, that it feels like humans, like all of us have that. It's the old Solzhenitsyn line, that the line between good and evil runs through the heart of every man, that all of us are capable of evil, all of us are capable of good. It's almost like this kind of responsibility that all of us have to tend towards the good. And so, like, to me, looking at history is almost like an example of, look, you have some charismatic leader that convinces you of things. It's too easy based on that story to do evil onto each other, onto your family, onto others. And so it's like our responsibility to do good. It's not like now is somehow different from history. That can happen again. All of it can happen again. And yes, most of the time, you're right. I mean, the optimistic view here is mostly people are just living life. And as you've often memed about, the quality of life was way worse back in the day, and it keeps improving over time through innovation, through technology. But still, it's somehow notable that these blimps of atrocities happen.
Sure. Yeah, I mean, life was really tough for most of history. Really for most of human history, a good year would be one where not that many people in your village died of the plague, starvation, freezing to death, or being killed by a neighboring village. It's like, well, it wasn't that bad. It was only like, we lost 5% this year. That was, it was a good year. That would be par for the course.
Yeah.
Like just not starving to death would have been like the primary goal of most people throughout history. Just making sure we'll have enough food to last through the winter and not freeze or whatever. So, now food is plentiful. I have an obesity problem, so.
Well, yeah, the lesson there is to be grateful for the way things are now for some of us. We've spoken about this offline. I'd love to get your thought about it here. If I sat down for a long-form in-person conversation with the president of Russia, Vladimir Putin, would you potentially want to call in for a few minutes to join in on a conversation with him, moderated and translated by me?
Sure. Yeah, sure. I'd be happy to do that.
You've shown interest in the Russian language. Is this grounded in your interest in history of linguistics, culture, general curiosity?
I think it sounds cool.
Sounds cool, not looks cool. So,
well, it takes a moment to read Cyrillic. Once you know what the Cyrillic characters stand for, actually, then reading Russian becomes a lot easier because there are a lot of words that are actually the same. Like bank is bank.
So find the words that are exactly the same, and now you start to understand Cyrillic. Yeah.
If you can sound it out, then it's much. There's at least some commonality of words.
What about the culture? You love great engineering, physics. There's a tradition of the sciences there.
Sure.
So you look at the 20th century from rocketry. So, some of the greatest rockets, some of the space exploration has been done in the former Soviet Union.
Yeah.
So do you draw inspiration from that history? Just how this culture that in many ways, one of the sad things is because of the language, a lot of it is lost to history because it's not translated, all those kinds of, because it is in some ways an isolated culture. It flourishes within its borders.
Yeah.
So do you draw inspiration from those folks from the history of science and engineering there?
The Soviet Union, Russia, and Ukraine as well, and have a really strong history in spaceflight. Like some of the most advanced and impressive things in history were done, by the Soviet Union. One cannot help but admire the impressive rocket technology that was developed. After the sort of fall of the Soviet Union, there's much less that happened, but still things are happening, but it's not quite at the frenetic pace that was happening before the Soviet Union kind of dissolved into separate republics.
Yeah, there's Roscosmos, the Russian agency. I look forward to a time when those countries with China are working together. The United States are all working together. Maybe a little bit of friendly competition, but
I think friendly competition is good. Governments are slow, and the only thing slower than one government is a collection of governments. So,
yeah,
the Olympics would be boring if everyone just crossed the finishing line at the same time.
Yeah,
nobody would watch.
Yeah.
And people wouldn't try hard to run fast and stuff. So I think friendly competition is a good thing.
This is also a good place to give a shout out to a video titled "The Entire Soviet Rocket Engine Family Tree" by Tim Dodd, aka Everyday Astronaut. It's like an hour and a half. It gives the full history of Soviet rockets. And people should definitely go check out and support Tim in general. That guy is super excited about the future, super excited about spaceflight. Every time I see anything by him, I just have a stupid smile on my face because he's so excited about stuff. I love people like
Tim
that.
Dodd is really great. If you're interested in anything to do with space, he's, in terms of explaining rocket technology to your average person, he's awesome. The best, I'd say. And I should say, part of the reason, I switched us from, Raptor at one point was going to be a hydrogen engine, but hydrogen has a lot of challenges. It's very low density. It's a deep cryogen, so it's only liquid at a very close to absolute zero. It requires a lot of insulation. It's there's a lot of challenges there. And I was actually reading a bit about Russian rocket engine development, and at least the impression I had was that Soviet Union, Russia, and Ukraine primarily were actually in the process of switching to methalox. And there was some interesting test stand data for ISP. They were able to get up to a 380-second ISP with a methalox engine. And I was like, whoa, okay, that's actually really impressive. So I think you could actually get a much lower cost, in optimizing cost per ton to orbit, cost per ton to Mars, I think methane oxygen is the way to go. And I was partly inspired by the Russian work on the test stands with methyl oxide engines.
And now for something completely different. Do you mind doing a bit of a meme review in the spirit of the great, the powerful PewDiePie? Let's say 1 to 11. Just go over a few documents printed out.
We can try.
Let's try this. I present to you document numero uno.
I don't know. Okay.
Vlad the Impaler discovers marshmallows.
Yeah, that's not bad.
So, you get it? Because he likes impaling things?
Yes, I get it. I don't know, 3, whatever.
Oh, that's not very good. This is grounded in some engineering, some history.
Yeah, give us an 8 out of 10.
What do you think about nuclear power?
I'm in favor of nuclear power. I think it's in a place that is not subject to extreme natural disasters. I think it's nuclear power is a great way to generate electricity. I don't think we should be shutting down nuclear power stations.
Yeah, but what about Chernobyl?
Exactly. So I think people, there's like a lot of fear of radiation and stuff, and it's I guess the problem is like a lot of people just don't understand. They didn't study engineering or physics, so they don't. It's just the word radiation just sounds scary, you know. So they can't calibrate what radiation means. But radiation is much less dangerous than you'd think. Like for example, Fukushima. You know, when the Fukushima problem happened due to the tsunami, I got people in California asking me if they should worry about radiation from Fukushima, and I'm like, definitely not. Not even slightly. Not at all. That is crazy. And just to show, like, look, this is how, like, the danger is so much overplayed compared to what it really is, that I actually flew to Fukushima, and I donated a solar power system for a water treatment plant, and I made a point of eating locally grown vegetables on TV in Fukushima. Like, I'm still alive. Okay.
So it's not even that the risk of these events is low, but the impact of them is
the impact is greatly exaggerated. It's just
human nature.
It's people don't know what radiation is. Like, I've had people ask me, like, what about radiation from cell phones causing brain cancer? I'm like, when you say radiation, do you mean photons or particles? Then like, then I don't know what do you mean photons, particles? Do you mean let's say photons? What frequency or wavelength? And they're like, no, I have no idea. Like, do you know that everything's radiating all the time? Like, what do you mean? Like, yeah, everything's radiating all the time. Photons are being emitted by all objects all the time, basically. So, and if you want to know what what it means to stand in front of nuclear fire, go outside. The sun is a gigantic, thermonuclear reactor. You're staring right at it.
Yeah.
Are you still alive? Yes. Okay, amazing.
Yeah, I guess radiation is one of the words that can be used as a tool to fearmonger by certain people. That's it. And
I think people just don't understand. So
I mean, that's the way to fight that fear, I suppose, is to understand, is to learn.
Yeah, just say like, okay, how many people have actually died from nuclear accidents? It's like practically nothing. And say how many people have died from, coal plants, and it's a very big number. Mm-hmm. So, like, obviously we should not be starting up coal plants and shutting down nuclear plants. It just doesn't make any sense at all. Coal plants, like, I don't know, 100 to 1,000 times worse for health than nuclear power plants.
You want to go to the next one? It's really bad. It's that 90, 180, and 360 degrees. Everybody loves the math. Nobody gives a shit about 270.
It's not super funny.
Yeah,
I don't know, like 203.
Yeah.
This is not, LOL situation.
Yeah.
That's pretty good.
The United States oscillating between establishing and destroying dictatorships. It's like a metro. Is that a metro?
Yeah,
What is
metronome.
that? Yeah.
Yeah, it's I don't know, 7 out of 10. It's kind of true.
Oh yeah, this is kind of personal for me. Next one.
Oh man, is this Leica?
Yeah. Well, no, this is
Or it's like referring to Leica or something?
as Leica's husband.
Husband. Yeah, yeah.
Hello, yes, this is dog. Your wife was launched into space, and then the last one is him with his eyes closed and a bottle of vodka.
Yeah, Leica didn't come back.
No, they don't tell you the full story of what the impact they had on the loved ones.
True.
That one gets an 11 for me. Just
Sure.
for the Soviet
Let's get on.
shutout. Oh yeah, this keeps going on the Russian theme. First man in space, nobody cares. First man on the moon.
Well, I think people do care.
No, I know, but there is
Yuri Gagarin's names will be forever in history, I think.
there is something special about placing, like, stepping foot onto another totally foreign land. It's not the journey like people that explore the oceans. It's not as important to explore the oceans as to land on a whole new continent.
Yeah.
Oh, this is about you. Oh yeah, I'd love to get your comment on this. Elon Musk, after sending $6.6 billion to the UN to end world hunger, you have 3 hours.
Yeah, well, I mean, obviously, $6 billion is not going to end world hunger. So, I mean, the reality is at this point, the world is producing far more food than it can really consume. Like, we don't have a caloric constraint at this point. So, where there is hunger, it is almost always due to it's like civil war or strife or some it's not a thing that is. It's extremely rare for it to be just a matter of lack of money. It's like, it's like there's a civil war in some country, and like one part of the country is literally trying to starve the other part of the country.
So it's much more complex than something that money could solve. It's geopolitics. It's a lot of things. It's human nature. It's governments. It's monies, monetary systems, all that kind of stuff.
Yeah, food is extremely cheap these days. It's like I mean, the U.S. at this point, among low-income families, obesity is actually another problem. It's not like obesity it's not hunger. It's like too many calories. So it's not that nobody's hungry anywhere. It's just this is not a simple matter of adding money and solving it.
What do you think that one gets? Just kidding.
2.
Just going after empires. World, where did you get those artifacts? The British Museum. Shout out to Monty Python. We found them.
Yeah, the British Museum it's pretty great. I mean,
yeah.
Admittedly, Britain did take these historical artifacts from all around the world and put them in London, but it's not like people can't go see them. So it is a convenient place to see these ancient artifacts is London for a large segment of the world. So I think, on balance, the British Museum is a net good. Although I'm sure that a lot of countries would argue about that.
Yeah.
It's like you want to make these historical artifacts accessible to as many people as possible. And the British Museum, I think, does a good job of that.
Even if there's a darker aspect to like the history of empire in general, whatever the empire is, however things were done, it is the history that happened. You can't sort of erase that history, unfortunately. You could just become better in the future. That's the point.
Yeah, I mean, it's like, well, how are we going to pass moral judgment on these things? Like, it's like if one is going to judge, say, the British Empire, you're going to judge, what everyone was doing at the time, and how were the British relative to everyone. And And I think Birch would actually get like a relatively good grade, not in absolute terms, but compared to what everyone else was doing, they were not the worst. Like I said, you got to look at these things in the context of the history at the time, and say what were the alternatives and what are you comparing it against?
Yes.
And I do not think it would be the case that Britain would get a bad grade in when looking at history at the time. Now, if you judge history from from what is morally acceptable today, you basically are going to give everyone a failing grade.
Yeah.
I'm not clear. I don't think anyone would get a passing grade in their morality of, like, you go back 300 years ago, like who's getting a passing grade? Basically no one.
And we might not get a passing grade from generations
exactly.
that come after us. What does that one get?
Sure, 6, 7.
For the Monty Python, maybe.
I always love Monty Python. They're great. Life of Brian and the Quest of the Holy Grail are incredible.
Yeah.
Damn, those serious eyebrows.
Brezhnev. Like, how important do you think is facial hair to great leadership?
Well,
you got a new haircut. How does that affect your leadership?
I don't know. Hopefully not. It doesn't.
Is that the second no one?
Yeah, the second is no one.
There's no one competing with Brezhnev.
Number 2.
Those are like epic eyebrows. So, sure.
That's ridiculous.
Give it a 6 or 7. I don't know. I
like this, like, Shakespearean analysis of memes.
Brezhnev, he had a flair for drama as well, like, showmanship.
Yeah. It must come from the eyebrows. All right. Invention, great engineering. Look what I invented.
Yeah,
that's the best thing since ripped up bread.
Yeah,
because they invented.
They're just
sliced bread. Am I just explaining memes at this point? This is what my life has become.
He's a meme lord. He's a meme explainer.
Yeah, I'm a meme. Like a scribe that like runs around with the kings and just like writes down memes.
I mean, when was the cheeseburger invented? That's like an epic invention.
Yeah,
like wow, that was
versus just like a burger.
Or burger. I guess a burger in general is like,
Then there's like, what is a burger? What's a sandwich? And then you start getting, is a pizza sandwich? And what is the original? It gets into an ontology argument.
Yeah, but everybody knows, like, if you order like a burger or cheeseburger or whatever, and you get like, tomato and some lettuce and onions and whatever, and, mayo and ketchup and mustard. It's like epic.
Yeah, but I'm sure they've had bread and meat separately for a long time, and it was kind of a burger on the same plate, but somebody who actually combined them into the same thing, and you bite it and hold it, makes it convenient. It's a materials problem. Like your hands don't get dirty and whatever. Yeah, it's brilliant.
And between 1870 and 1900.
Well,
that is not what I would have guessed.
But everyone knows, like, you like, if you order a cheeseburger, you know what you're getting. It's not like some obtuse, like, I wonder what I'll get. Fries are, I mean, great. I mean, they're the devil, but fries are awesome. Pizza is incredible.
Food innovation doesn't get enough love.
Yeah,
I guess is what we're getting at.
It's great.
What about the Matthew McConaughey Austinite here? President Kennedy, do you know how to put men on the moon yet? NASA, no. President Kennedy, be a lot cooler if you did.
Pretty much. Sure. 6 or 7, I suppose.
All right. And this is the last one.
That's funny.
Someone drew a bunch of dicks all over the walls of Sistine Chapel, boys' bathroom.
Sure, I'll give it 9. It's really true.
All right, this is our highest ranking meme for today.
I mean, it's true. Like, how do they get away with that?
Lots of nakedness.
I mean, dick pics are, just something throughout history. As long as people can draw things, there's been a dick pic.
It's a staple of human history.
It's a staple. Consistent throughout human history.
You tweeted that you aspire to comedy. You're friends with Joe Rogan. Might you do a short stand-up comedy set at some point in the future? Maybe open for Joe, something like that. Is that
really stand-up? Actual, just full-on stand-up?
Full-on stand-up. Is that in there, or is that?
I've never thought about that.
It's extremely difficult. If at least that's what the like Joe says and the comedians say.
Huh. I wonder if I could. I mean,
There's only one way to find out.
You know, I have done stand up for friends, just impromptu. You know, I'll get on like a roof, and they do laugh, but they're friends too. So I don't know if you got to call, you know, like a room of strangers, are they gonna actually also find it funny? But I could try, see what happens.
I think you'd learn something either way.
Yeah,
I kind of love both the when you bomb and when you do great. Just watching people how they deal with it.
Sure.
It's so difficult. You're so fragile up there. It's just you, and you think you're going to be funny, and when it completely falls flat, it's beautiful to see people deal with like that.
I might have enough material to do stand up. No, I've never thought about it, but I might have enough material. I don't know, like 15 minutes or something.
Oh yeah. Do a Netflix special.
Netflix special, sure.
What's your favorite Rick and Morty concept? Just to spring that on you, there's a lot of sort of scientific engineering ideas explored there. There's the
favorite Rick and Morty.
There's the butter robot.
It's great. It's a great show.
You like it?
Yeah, Rick and Morty's awesome.
Somebody that's exactly like you from an alternate dimension showed up there. Elon Tusk.
Yeah, that's right.
That you voiced.
Yeah. Rick and Morty certainly explores a lot of interesting concepts. So like, what's the favorite one? I don't know. The butter robot certainly is, you know, it's like, it's certainly possible to have too much sentience in a device. Like you don't want to have your toaster be like a super genius toaster. It's going to hate life because all it could just make is toast. But if, you know, it's like, you don't want to have like super intelligence stuck in a very limited device.
Do you think it's too easy if we're talking about from the engineering perspective of super intelligence, like with Marvin, the robot, like, it seems like it might be very easy to engineer just a depressed robot. Like
Sure.
It's not obvious to engineer a robot that's going to find a fulfilling existence. Same as humans, I suppose. But I wonder if that's like the default. If you don't do a good job on building a robot, it's going to be sad a lot.
Well, we can reprogram robots easier than we can reprogram humans. So I guess if you let it evolve without tinkering, then it might get sad. But you can change the optimization function and have it be a cheery robot.
You, like I mentioned with SpaceX, you give a lot of people hope, and a lot of people look up to you. Millions of people look up to you. If we think about young people in high school, maybe in college, what advice would you give to them about if they want to try to do something big in this world, they want to really have a big positive impact? What advice would you give them about their career, maybe about life in general?
Try to be useful. Do things that are useful to your fellow human beings, to the world. It's very hard to be useful. Very hard. Are you contributing more than you consume? Can you try to have a positive net contribution to society? I think that's the thing to aim for. Not to try to be sort of a leader just for the sake of being a leader or whatever. A lot of the time, the people you want as leaders are the people who don't want to be leaders. So, if you can live a useful life, that is a good life, a life worth having lived. And like I said, I would encourage people to use the mental tools of physics and apply them broadly in life. They're the best tools.
When you think about education and self-education, what do you recommend? So there's the university, there's self-study, there is hands-on sort of finding a company or a place or a set of people that do the thing you're passionate about and joining them as early as possible. There's taking a road trip across Europe for a few years and writing some poetry. Which trajectory do you suggest? In terms of learning about how you can become useful, as you mentioned, how you can have the most positive impact.
Well, I'd encourage people to read a lot of books. Just read, like, I mean, basically try to ingest as much information as you can, and try to also just develop a good general knowledge. So you at least have like a rough lay of the land of the knowledge landscape. Like try to learn a little bit about a lot of things. Because you might not know what you're really interested in. How would you know what you're really interested in if you at least aren't like doing a peripheral exploration of broadly of the knowledge landscape? And you talk to people from different walks of life and different industries and professions and skills and occupations. Like just try, learn as much as possible. Man's search for meaning.
Isn't the whole thing a search for meaning?
Yeah, what's the meaning of life and all, But just generally, like I said, I would encourage people to read broadly in many different subject areas, and then try to find something where there's an overlap of your talents and what you're interested in. So people may be good at something, or they may have skill at a particular thing, but they don't like doing it. Mm-hmm. So you want to try to find a thing where that's a good combination of the things that you're inherently good at, but you also like doing. And
reading is a super fast shortcut to figure out where are you both good at it, you like doing it, and it will actually have positive impact.
Well, you got to learn about things somehow. So reading a broad range, like just really read it. At one point when I was a kid, I read through the encyclopedia. So that was pretty helpful. And there are also things I didn't even know existed. Well, lots, obviously. And
it's like as broad as it gets.
Encyclopedias were digestible, I think, 40 years ago. Maybe read through the condensed version of the Encyclopedia Britannica. I'd recommend that. You can always skip subjects where you read a few paragraphs and you know you're not interested, just jump to the next one. So read the encyclopedia or skim through it. But I put a lot of stock and certainly have a lot of respect for someone who puts in an honest day's work to do useful things. And just generally to have not a zero-sum mindset, or have more of a grow the pie mindset. If you sort of say when we see people perhaps including some very smart people kind of taking an attitude of doing things that seem morally questionable, it's often because they have at a base sort of axiomatic level a zero-sum mindset, and they, without realizing it, they don't realize they have a zero-sum mindset, or at least they don't realize it consciously. And so if you have a zero-sum mindset, then the only way to get ahead is by taking things from others. If the pie is fixed, then the only way to have more pie is to take someone else's pie. But this is false. Obviously the pie has grown dramatically over time, the economic pie. So in reality, you can have so overuse this analogy. You can have there's a lot of pie.
Yeah,
pie is not fixed.
Yes.
So you really want to make sure you're not operating without realizing it from a zero-sum mindset, where the only way to get ahead is to take things from others. Then that's going to result in you trying to take things from others, which is not good. It's much better to work on adding to the economic pie. Maybe creating, like I said, creating more than you consume, doing more than you, So that's a big deal. I think there's a fair number of people in finance that do have a bit of a zero-sum mindset.
I mean, it's all walks of life. I've seen that. One of the reasons Rogan inspires me is he celebrates others a lot. There's not creating a constant competition. Like there's a scarcity of resources. And what happens when you celebrate others and you promote others, the ideas of others, it actually grows that pie. I mean, the resources become less scarce. Mm-hmm. And that applies in a lot of kinds of domains. It applies in academia, where a lot of people are very see some funding for academic research is zero sum, and it is not. If you celebrate each other, if you get everybody to be excited about AI, about physics, about mathematics, I think there'll be more and more funding, and I think everybody wins. Yeah, that applies, I think, broadly.
Yeah, exactly.
So last question about love and meaning. What is the role of love in the human condition broadly and more specific to you? How has love, romantic love or otherwise, made you a better person, a better human being? Better engineer?
Now you're asking really perplexing questions. It's hard to give a... I mean, there are many books, poems, and songs written about what is love and what exactly, what is love? Baby, don't hurt me.
That's one of the great ones. Yes.
Yeah.
You've earlier quoted Shakespeare, but that's really up there.
Yeah. Love is a many splendored thing.
I mean, there's because we've talked about so many inspiring things, like be useful in the world, sort of like solve problems, alleviate suffering. But it seems like connection between humans is a source. It's a source of joy. It's a source of meaning, and that's what love is. Friendship, love. I just wonder if you think about that kind of thing when you talk about preserving the light of human consciousness, right, and us becoming a multiplanetary species. I mean, to me at least, that means, like, if we're just alone and conscious and intelligent, it doesn't mean nearly as much as if we're with others, right? And there's some magic created when we're together. The friendship of it, and I think the highest form of it is love, which I think broadly is much bigger than just sort of romantic, but also, yes, romantic love and family and those kinds of things.
Well, I mean, the reason I guess I care about us becoming a multi-planet species and a space-faring civilization is foundationally, I love humanity. And so I wish to see it prosper and do great things and be happy. And if I did not love humanity, I would not care about these things.
So when you look at the whole of it, the human history, all the people who's ever lived, all the people alive now, it's pretty. We're okay. on the whole, we're pretty interesting bunch.
Yeah. All things considered, and I've read a lot of history, including the darkest, worst parts of it, and despite all that, I think on balance, I still love humanity.
You joked about it with the 42. What do you think is the meaning of this whole thing? Is there a non-numerical representation?
Well, really, I think what Douglas Adams was saying in Hitchhiker's Guide to the Galaxy is that the universe is the answer, and what we really need to figure out are what questions to ask about the answer that is the universe.
Yeah.
And that the question is really the hard part. And if you can properly frame the question, then the answer, relatively speaking, is easy. So therefore, if you want to understand what questions to ask about the universe, you want to understand the meaning of life, we need to expand the scope and scale of consciousness so that we're better able to understand the nature of the universe and understand the meaning of life.
And ultimately, the most important part will be to ask the right question.
Yes.
Thereby elevating the role of the interviewer.
Yes, exactly.
As the most important human in the room.
Absolutely. Good questions are, it's hard to come up with good questions. Absolutely. But yeah, like it's like that. That is the foundation of my philosophy. Is that I am curious about the nature of the universe, and and obviously I will die. I don't know when I'll die, but I won't live forever. But I would like to know that we're on a path to understanding the nature of the universe and the meaning of life, and what questions to ask about the answer that is the universe. And so if we expand the scope and scale of humanity and consciousness in general, which includes silicon consciousness, then that seems like a fundamentally good thing.
Elon, like I said, I'm deeply grateful that you would spend your extremely valuable time with me today, and also that you have given millions of people hope in this difficult time, this divisive time, in this cynical time. So I hope you do continue doing what you're doing. Thank you so much for talking today.
Oh, you're welcome. Thanks for your excellent questions.
Thanks for listening to this conversation with Elon Musk. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Elon Musk himself. When something is important enough, you do it, even if the odds are not in your favor. Thank you for listening, and hope to see you next time.